Hemos vuelto después del coffee break. Bien, les pido, por favor, que silencien sus celulares. Bueno, y también lo de siempre, no se puede traer aquí comida o café, ¿cierto? Por seguridad. Ahora tengo el placer, el gusto de comenzar con el primer panel después de la magnífica charla inaugural que nos dio Ángel. Tengo el gusto de presentar el panel número 1, que se denomina Panorama de Actividades Lunares y Recursos Espaciales. Bueno, les advierto a los expositores que cuando falten 5 minutos les voy a avisar que quedan 5 minutos y tienen que terminar, ¿cierto? Para cumplir con los tiempos. El moderador de este panel, denominado Panorama de Actividades Lunares y Recursos Espaciales, es el señor Carlos Espejel. Carlos es director ejecutivo y fundador de Space, empresa, consultoría y tecnología con sede en Luxemburgo, de amplia experiencia en el ámbito de desarrollo espaciales, tecnología espacial y también uno de nuestros inspiradores para el desarrollo de los recursos espaciales aquí en Chile. Carlos se va a hacer cargo de este panel, va a ser el moderador, ¿cierto? Y primero va a presentar él su presentación, que se va a denominar Perspectivas Comercial de Misiones Lunares y los Recursos Espaciales. Entonces invito a Carlos, aquí adelante Carlos, a su presentación y luego él va a seguir presentando a los siguientes expositores.
Bueno, muchas gracias por la presentación y de nuevo bienvenidos al panel número 1, el cual se titula Panorama de Actividades Lunares y de Recursos Espaciales. Va a ser un panel bastante interesante, vamos a tener expertos que vienen de diferentes países, de Estados Unidos, de Australia, de Luxemburgo, y es gente que vive, trabaja, respira los recursos espaciales todos los días. Y bueno, con esto, también el panel va a durar alrededor de 2 horas, pero puede ser que terminemos un poquito antes para salir al almuerzo y ya les avisaremos. Bueno, como soy el moderador, también tengo la oportunidad de ser el primer presentador y mi charla, de nuevo, se titula Perspectiva Comercial de Misiones Lunares y Recursos Espaciales. Con esto me voy a presentar rápidamente para que conozcan un poco de mí y luego les voy a dar un poquito de historia de cómo misiones de alunizajes fueron de ser solamente actividades gubernamentales, actividades comerciales también. Es un poquito de historia ahí. Luego vamos a platicar rápidamente sobre recursos lunares y la parte económica, financiera, con números duros, de qué significa este tipo de economía de recursos espaciales. Muy bien, y me gustaría empezar con una frase, la cual es: la Luna no es solo un destino político y científico, ahora es un destino también económico y político. Y vamos a hablar más sobre eso. Un poquito de mi experiencia académica, ya que teníamos al embajador de Australia. Yo estudié en Australia, soy ingeniero mecánico, ingeniero de minas. Luego hice una maestría de ingeniería de minas con el doctor Serkan Seydam, el cual tenemos aquí presente, con el cual yo conocí sobre los recursos espaciales. Luego hice un doctorado en la Universidad de Queensland y tuve la oportunidad de hacer un postdoctorado en Luxemburgo. En la parte de experiencia me gustaría compartirles que yo empecé con Extrata Glencore, en donde uno de mis grandes mentores es chileno y ahorita está a cargo de posiciones muy altas en Anglo American. Entonces, de mis grandes mentores como ingeniero de minas son chilenos. De ahí luego tuve la oportunidad de trabajar para iSpace por más de 6 años y después de iSpace tuve la oportunidad de fundar mi propio negocio, mi propia empresa, la cual se llama SpaceRS, y nos enfocamos en lo que es planificación estratégica de minas terrestre y también planificación de minas en la Luna, en el espacio, y también identificamos tecnologías que se pueden utilizar para la industria minera en específico. Bueno, pero démosle directo. Bueno, y como van a ver con mi acento, yo soy mexicano, ¿ya? Pero he vivido bastante tiempo afuera del país, es que perdonen un poquito mi español. Pero bien, démosle directo. Les voy a contar un poco sobre la historia de cómo los alunizajes fueron de actividades de gobierno a actividades también comerciales. Pero la primera pregunta es, ¿por qué fuimos a la Luna como humanidad? ¿Por qué fuimos para ahí? La primera es porque es nuestra condición humana. Como humanos queremos explorar, queremos expandirnos, y al mismo tiempo es lógico, es nuestro cuerpo celeste más cercano a la Tierra, Pero uno de los más importantes es que siempre necesitamos un motivo. Y en este momento el motivo fue la Guerra Fría. La Guerra Fría entre la Unión Soviética y Estados Unidos, y empezó la Unión Soviética ganando la carrera espacial, en donde en 1966 alunizan controladamente con el primer alunizador. Empiezan ganando la carrera. De ahí Estados Unidos, como bien lo sabemos, después de muchas misiones, alunizan, hacen un hito histórico en 1969 con el Apolo 11, donde el famoso Neil Armstrong y Buzz Aldrin pisan la Luna. Pero bueno, después de 5 alunizajes más en la Luna del programa Apolo y 6 aterrizajes robóticos del programa Surveyor, la NASA tiene su última misión lunar, que es el Apolo 17. Y este es muy importante porque es la única vez que se mandó un geólogo, imagínense, es ultra importante, que pisa la Luna, ¿ya? Y bueno, al mismo tiempo desplegaron un carro lunar donde los astronautas estuvieron manejando más de 35 kilómetros. Ahora, la última misión lunar no fue de Estados Unidos, fue de Rusia, donde en 1976 alunizan robóticamente, toman alrededor de 170 gramos de muestras, como lo mencionó Ángel, y lo regresaron a la Tierra. Pero de toda esa carrera de la Guerra Fría, de la carrera lunar, la última misión, la primera fue de la Unión Soviética y la última fue de la Unión Soviética. Pero ¿qué sucedió durante los 60s y los 70s? Era una carrera política, tecnológica y de poder. Pero ese motivo se terminó. Y al mismo tiempo que ese motivo se terminó, los costos eran gigantescos. En ese momento, el Apolo 11 costó entre 35 y 40 billones de dólares, nada más por mandar una misión. Si eso lo transformamos a kilogramos de carga útil, el costo era de 160 millones de dólares por un kilogramo en la superficie. Recordemos ese número, 160 millones de dólares por kilogramo. Y por lo tanto se cierra la carrera espacial. ¿Qué pasó? Pasaron 36 años. Pasaron 36 años sin actividad lunar. ¿Y quién llega? Llega China. Llega China en el 2013, donde se convierte en el tercer país, la tercera nación de pisar la Luna. Y no solo eso, también desplegan un robot, el famoso U-2-1, que empieza a hacer prospección y mapeo en la superficie. Y como lo mencionó Ángel, algo muy importante pasó en el 2015. Básicamente, Estados Unidos crea marcos legales para que sus empresas basadas en Estados Unidos puedan trabajar comercialmente con recursos espaciales. Y firmaron el famoso Commercial Space Launch Competitiveness Act. Bien, de ahí pasemos al 2017, donde Luxemburgo sigue la misma línea. Luxemburgo firma la famosa Ley de Exploración y Uso Comercial de Recursos Espaciales, la cual permite que compañías basadas en Luxemburgo puedan trabajar en el tema de recursos espaciales comercialmente. Y esa es una de las razones por la que mi compañía, SpaceRS, está basada en Luxemburgo. Bueno, pero pasemos al 2019. El 2019 es un año súper importante, y lo recordemos. ¿Por qué? Fue el año donde Estados Unidos, Europa y el mundo se compromete a regresar a la Luna. La otra, SpaceX, sale al estrado y con el Falcón 9 baja los precios de acceso al espacio. Y al mismo tiempo es un año importante para lo que son los alunizadores comerciales. Pero que no se nos olvide, también fue un año importante para China. Y empecemos con China, porque China aluniza una vez más el 3 de enero de 1919 con otro hito histórico. Aterrizan por primera vez en la cara oculta de la Luna. Y no solo eso, desplegan un robot, toman muestras y empiezan a hacer prospección también de recursos. Obviamente, Estados Unidos no se tiene que quedar atrás y fue muy importante en el 2019. En primera, anuncian el programa Artemisa. En segunda, anuncian el programa Eclipse. El programa Eclipse nos van a presentar un poco más de iSpace, que es un programa donde la NASA escoge empresas comerciales para desarrollar alunizadores y que estas empresas comerciales puedan mandar carga útil de la NASA a la Luna comercialmente y ponen billones de dólares en esto. La segunda, anuncian de que los humanos van a regresar a la Luna, la cual se pospuso, como todos lo sabemos, y la otra se crea el famoso Space Force. O sea, este año es muy importante, 2019. Y luego Mike Pence dice un enunciado muy interesante, donde dice, la NASA ahora sabe sobre el gran valor que tiene el Polo Sur, científico, económico y estratégico, y es hora de regresar. O sea, fue un anuncio global donde dijeron regresamos, y no solo por ciencia, sino estratégico y económico. Por lo tanto, la Unión Europea, ellos también se comprometen con 14.4 billones de dólares, que es la inversión más grande que han puesto de presupuesto en su agencia espacial, destinada para el espacio, pero gran parte para la parte de exploración. Bien, regresemos a SpaceX. SpaceX, todos lo conocemos, Elon Musk saca el Falcon 9 y básicamente abre el acceso al espacio de una forma mucho más barata. Para que se den cuenta, antes, si querías mandar algo a órbita baja, te costaba hasta $40,000 por kilogramo. Si querías mandar algo a órbita baja, $40,000 por kilogramo. Con el Falcon 9, baja el precio hasta $2,700 por kilogramo. Y si quieres compartir el cohete, puedes pagar hasta $1,000 por kilogramo. Entonces, básicamente, abre las puertas al espacio. Y una vez abiertas, sale el primer cliente de SpaceX, que es una empresa privada de alunizadores de Israel, los cuales tratan de alunizar en abril de 2019. Desafortunadamente, por problemas logísticos y de equipo, no lograron aterrizar y chocaron. Sin embargo, ISRO, que es la Agencia Espacial de la India, también trata de aterrizar, pero esta vez en el polo sur de la Luna, porque como nos comentó Ángel, existe el agua y entre otros elementos. Sin embargo, desafortunadamente, nos recuerdan que no es fácil aterrizar en la Luna y también chocaron. Pero para cerrar con broche de oro el 2019, los Emiratos Árabes Unidos también crean su marco legal para que sus entidades en los Emiratos puedan trabajar con recursos espaciales. Y aquí mi pregunta para Chile es, ¿cuándo va Chile a crear su marco legal para que entidades chilenas puedan trabajar en temas espaciales? Que no se nos olvide China, de nuevo, en el 2020, con Chang'e 5 aterrizan, pero esta vez traen una perforadora. La perforadora baja 1 metro, toma muestras y no solo eso, las regresa a la Tierra para analizarlas en la Tierra. O sea, los chinos con Chang'e 5 van muy, muy adelantados. Bien, para esto Japón también sigue la línea. Ellos también crean su famoso Space Resources Act, donde compañías japonesas pueden comercialmente trabajar con el tema de recursos espaciales. Y entre ellos es iSpace, el cual van a presentar más adelante. Y de nuevo, la pregunta aquí es, ¿cuándo Chile va a crear su marco legal de recursos espaciales? Bien, ok, entonces, básicamente, para el 2021, lo que son los marcos legales ya están puestos. Y para eso, entonces, empresas comerciales pueden empezar la carrera comercial de recursos espaciales. Y la primera empresa comercial que toma ese paso es iSpace, los cuales van a presentar después, donde en el 2023 se convierten en la primera empresa comercial de llegar a la Luna. Y no solo eso, sino también llevaban un contrato de recursos espaciales de la NASA. Ahora, desafortunadamente, de hecho llegaron a la Luna. Este es un video de iSpace, es un video real. De nuevo, se convierten en la primera empresa comercial de llegar a la Luna, pero desafortunadamente chocaron, ¿ya? Pero lo hicieron muy bien. Luego, en el 2023, los rusos con Roscosmos tratan de alunizar de nuevo en la Luna y nos recuerdan que alunizar no es fácil. Pero para esto, la Agencia Espacial de la India nos recuerda que sí es posible. La Agencia Espacial de la India aluniza y se convierte en el 4º país de alunizar controladamente en la Luna. Y no solo eso, sino también desplegan un robot y toman la foto que estamos viendo en la pantalla. Ahora, Japón no se podía quedar atrás. Japón, en enero del 2024, se convierte en el 5º país de alunizar controladamente en la Luna. Es un aterrizador bastante interesante porque alunizaba de lado. Desplegó un robot, el cual es el que tomó la foto y tomó diferentes fotos. Bien, si nos estamos dando cuenta, son demasiadas misiones lunares. Bien, en el 2024 también una empresa comercial de Estados Unidos trata de alunizar en la Luna. Sin embargo, tuvieron problemas mecánicos, no llegaron a órbita lunar, tuvieron que regresar y estrellarse en la Tierra, creo que en el Pacífico, cerca de Australia. Aún así, otra empresa comercial de Estados Unidos llamada Intuitive Machines, con su IM-1, logran alunizar controladamente en febrero del 2024. Sin embargo, se convirtieron en la primera empresa comercial de casi alunizar controladamente. alunizaron controladamente y al alunizar se tropezaron y quedaron de lado. Y por esa razón no se le dio básicamente la estrellita de los primeros, pero lo hicieron muy bien. Y que no se nos olvide China. China en el 2024, el 1 de junio, aluniza una vez más en la cara oculta de la Luna con una perforadora de exploración, toma muestras a 1 metro de profundidad y no solo eso, las regresa a la Tierra para evaluarlas. Ahora, no es secreto de nadie que China está también muy interesado en los recursos espaciales, incluyendo las tierras raras. Bien, ok, eso es hasta el 2024, el año pasado, pero ¿qué está sucediendo este año? Este año lo logramos. Básicamente, la primera empresa de alunizadores comerciales logra alunizar controladamente. Y esta es la empresa llamada Firefly Aerospace, donde de nuevo se convierte en la primera empresa comercial que logra alunizar. Para esto les voy a mostrar un video, el cual a mí me encanta y a todos los de la industria nos gusta mucho, y espero que a ustedes también les parezca interesante.
Blue Ghost Riders, the path to the stars is no longer limited to nations alone. Firefly is building the road to the next frontier, one mission and one dream at a time. Tonight, we didn't just reach another mission milestone. Together, we created a moment in history.
Khan, Chief Engineer on Ops. Y'all select the landing. We're out the moon.
Bueno, la verdad es un video impresionante y cada vez que lo veo me sigue impresionando, pero lo más importante es felicitar una vez más a Firefly Aerospace por abrir las puertas comerciales de carga útil a la Luna. Literal, ahora ya cualquier entidad puede pagar, que ahorita les voy a mostrar unos precios, pero puede llevar una carga útil a la Luna. Y Firefly nos ha abierto las puertas. Así que gracias Firefly una vez más. Pero esto no ha terminado. O sea, esto fue en febrero de este año. Y después de ellos, una semana después, de nuevo, Intuitive Machines, con el IM-2 Odysseus, trata de aterrizar. Ahora, alunizar. Y esta vez alunizan igual, perfecto, controladamente, alunizan y se tropiezan de nuevo. Y esa imagen que ven en la pantalla es justamente desde su aterrizador, tropezados. Pero alunizaron perfectamente. Y ahí venía también el primer rover comercial de Lunar Outpost, del cual lo voy a platicar un poco más adelante. Ahora, este mismo año, véanlo en las noticias, el siguiente alunizaje es de parte de iSpace, el cual nos va a presentar un poco más adelante, Marshall, y tienen planeado alunizar en junio de este año. Y bueno, eso no es todo. Después, Intuitive Machines va a tratar de alunizar una vez más después de este año y luego Astrobotic. Son demasiadas misiones. O sea, básicamente, del 2019 al 2025 hay 9 misiones comerciales privadas de alunizaje y alrededor de 7 misiones de agencias espaciales. Si se dan cuenta, son más misiones comerciales. Entonces, ahí tenemos 16 misiones de alunizaje. Ahora, entre el 2026 y el 2035, tenemos más de 30 misiones planeadas comerciales de alunizaje y más de 20 misiones de las agencias espaciales. O sea, tenemos más de 50 misiones de aquí al 2035 de las que están planeadas. La pregunta es, ¿por qué todos tienen tanta prisa de llegar a la Luna? ¿Por qué tantas misiones de aterrizar? Y ahorita lo vamos a ver. Pero bueno, entre las agencias espaciales que están trabajando en el tema lunar, los típicos, NASA, ESA, Luxemburgo, Canadá, China, Australia, Arabia Saudita, Brasil, Rusia, los Emirates, Corea del Sur, México y esperemos que muy pronto Chile, ¿ya? Y a través de las Fuerzas Aéreas chilenas o a través de la creación de una agencia espacial. Esa es la invitación número 2 para Chile. Y bueno, en la imagen del otro lado son empresas comerciales que en este momento han tenido o tienen actividades lunares y entre ellas pueden ver allá a Epiroc, que viene de la industria minera. Muy bien, pero de nuevo la pregunta es, ¿por qué todo el mundo quiere ir a la Luna? Y obviamente son muchas razones, pero entre ellas es de que la Luna está llena de recursos naturales. Y la otra es que tenemos motivos como humanos. Y el motivo ahora no solo es científico, obviamente todavía es científico, pero ahora viene la parte económica y estratégica. Y la otra es de que los precios de carga útil en la superficie lunar han bajado muchísimo. Si recuerdan, anteriormente costaba $160 millones poner 1 kilogramo en la superficie, y ahora vale menos de 1.5 millones por kilogramo en la superficie. Si gustan negociar carga útil en la Luna, aquí tenemos a iSpace, pueden con ellos negociar carga útil a la Luna. Pero una vez que empieza a trabajar el Starship, el precio va a bajar a más de $30,000 por kilogramo y por ahí se dice que de hecho menos de $10,000 por kilogramo. Por lo tanto, el acceso de actividad lunar está abierto y el precio va a bajar más todavía. Bien, rápidamente, Ángel nos dio una excelente presentación presentando todos los recursos espaciales, pero lo vamos a resumir rápidamente y ahorita vamos a ver por qué. En la Luna, a través de las agencias espaciales, sabemos que hay mucho hierro, magnesio, aluminio, calcio, silicio, thorium, uranio, potasio, fósforo, tierras raras, y por eso los países están yendo a la Luna, titanio, sodio, oxígeno, como lo comentó Ángel, hay demasiado oxígeno, hay hidrógeno nativo y también hay helio 3 nativo, como lo estaba comentando Ángel. Pero de los descubrimientos más importantes es de que hay agua en los polos. Y también, como lo mencionaba Ángel, se ha estimado que hay más de 10 billones de toneladas en los primeros 2 metros. Y uno de los primeros mercados es el reabastecimiento de combustible para cohetes, satélites, alunizadores, etc. Entonces, lo que podemos ver hasta este momento es que la Luna tiene muchos recursos y hay una urgencia por la parte de las naciones y entidades comerciales de ir a la Luna. Y aquí me gustaría que recordáramos algo. ¿Recuerdan la carrera de recursos naturales del siglo XVI, de 1500, donde Europa mandó muchos galeones a las Américas, a Chile, a Perú, a México, para explorar por recursos, la cual cambió por completo el mundo, transformó el mundo? Y les voy a dar unos números. España mandó más de 1,000 galeones, mandaba entre 15 y 45 galeones por año, si ya están viendo ahí la analogía. Portugal mandó entre 400 y 500 galeones, ellos mandaban de 2 a 6 galeones por año. Inglaterra mandó menos de 100 galeones por año. Sin embargo, los ingleses fueron muy innovadores. Ellos crearon nuevos modelos económicos y también crearon asociaciones públicas privadas, que son los famosos corsarios. Pero ese es otro tema para discutir después. Pero el tema aquí es de que hubo ya una carrera de recursos espaciales, recursos naturales, de las cuales aprendimos mucho, ¿ya? Y ahora tenemos una nueva carrera de recursos naturales del siglo XXI, la cual ahora estamos mandando alunizadores con la misma razón, para explorar por recursos y vamos a transformar el futuro, ¿ya? Ahora, En el pasado, básicamente, el nuevo mundo era atravesando el Atlántico, atravesando el océano. Ahora el nuevo mundo va a ser atravesando el espacio. Y acá me gustaría enfatizar algo. Es la oportunidad como humanos para no volver a repetir todos esos errores que hicimos en ese momento y de que reescribamos la historia, no a través de la conquista, pero a través de la colaboración, la cual se estuvo platicando bastante, y que podamos compartir la prosperidad. ¿Ya? Ahora, hablando de prosperidad, quiero compartirles un resumen de estudios socioeconómicos y técnicos que se han hecho de recursos espaciales. Bien, hay dos estudios bastante famosos. Uno de ellos es el Commercial Lunar Propellant Architecture y el otro es el famoso estudio de PwC con el gobierno de Luxemburgo. Ahora, el estudio del gobierno de Luxemburgo encontró muchas cosas, pero entre ellas encontró que este nuevo mercado de recursos espaciales puede generar cajas de flujo de más de 170 billones de euros entre el 2018 y el 2045. Al mismo tiempo, esta nueva economía puede crear más de hasta 1.8 millones de empleos de tiempo completo. Y como lo vimos en la presentación anterior, hay compañías como ULA que quieren comprar ese combustible en el espacio. Entonces, estas compañías que compren recursos, combustible hecho en la Luna, van a poder ahorrar hasta 254 billones de euros. Ahora, también como lo platicamos, para explorar recursos espaciales vamos a tener que inventar tecnologías de exploración, de extracción, de proceso, y esas tecnologías las vamos a poder aplicar a la industria terrestre, ¿ya? Y esa tecnología se evalúa hasta más de 135 billones de euros, ¿ya? Ahora, el estudio también dice, la Luna es primero, es prioridad, empecemos con el agua y con el combustible. ¿Cómo llegaron a esa conclusión? Evaluaron todas las opciones. Empezaron con la Luna y sus recursos, con los asteroides, con Marte, vieron los diferentes mercados, vieron lo que es el combustible, los propulsores, lo que son el life support, infraestructura, equipo y también en algún momento traer esos recursos de regreso a la Tierra. Y lo que vieron fue el corto, mediano y largo plazo, ¿ya? Entre las cosas que encontraron fue que hay que empezar con el combustible y también una de sus findings de lo que encontraron es de que la industria minera debe que estar en este momento involucrada y contribuyendo en el tema de recursos espaciales. Y esta es mi tercera invitación para que Chile, como industria minera, empiece a participar en el tema de recursos espaciales activamente. Ahora, se encontraron muchos riesgos, pero uno de ellos es el riesgo geológico, que básicamente lo que dice es de que no tenemos el suficiente conocimiento geológico, hay que explorar mucho, hay que llevarlo de recursos prospectivos a reservas, ¿ya? Y para eso estamos trabajando en nuevos estándares como tipo York, que se llama de hecho el LUNARS 01, ¿ya? Bien, entonces el estudio dice empezamos con la Luna y con agua, y luego con los asteroides, etcétera. Luego el otro estudio, el que se llama Commercial Lunar Propellant Architecture, también empieza a definir quiénes son los clientes. Y como Ángel lo dijo muy bien, primero van a ser las agencias espaciales, como la NASA, la ESA, China, Rusia, y también luego las compañías comerciales, como SpaceX, etc. Pero este estudio, también muy interesante, ya está básicamente proponiendo una arquitectura en donde se va a reabastecer y vender este combustible. Y se va a reabastecer y vender en órbita baja, en órbita geoestacionaria, en puntos Lagrange, en órbita lunar. Pero acá un punto importante que quiero mostrarles es de que calcularon que se necesitan 1.640 millones de toneladas por año de producción de combustible en la Luna, ¿ya? Es bastante. Bien, y un ejemplo concreto es SpaceX, donde ellos están desarrollando tecnología para reabastecimiento de combustible, de propulsor, el cual necesitan para llegar a Marte. O sea, si ellos no se reabastecen en órbita baja, en la Luna, no van a llegar a Marte. Y una vez que lleguen a Marte, necesitan reabastecer para regresar a la Tierra. Muy bien. Hay muchos posibles clientes, pero ¿quién va a ser el primer cliente de recursos espaciales? Y para esto, obviamente, fue la NASA, donde ellos básicamente dieron los 4 primeros contratos de recursos espaciales. Y los primeros en la historia. Y básicamente dan 4 contratos donde dicen, necesitamos que una empresa comercial llegue a la Luna por sí sola, saque un sistema, recoja 50 gramos de regolito y nos lo venda legalmente y comercialmente. Entonces, esto realmente, el objetivo era para poner a prueba los marcos legales que estuvimos viendo. Empresas comerciales compitieron y contratos, 2 se ganó iSpace y otro se los ganó Lunar Outpost. Y Lunar Outpost desarrolló un rover que hace diferentes cosas, pero entre ellas colecta los 50 gramos para venderlos a la NASA. Sin embargo, desafortunadamente, iban en la misión de Intuitive Machines y no lograron sobrevivir. Pero iSpace va a estar aterrizando en junio de este año, donde ellos van a tratar de ejecutar el primer contrato de minería espacial en la historia, que es el cliente es la NASA. Y yo creo que a lo mejor Marshall nos va a platicar un poco más sobre ello. Y bueno, aquí quería mencionarles que ese cargador frontal de iSpace fue desarrollado con Epiroc y fue el primer partnership, asociación, entre una empresa espacial y minera, en la cual tengo el orgullo de decir que trabajé en ese proyecto. Bien, ok, pero estos contratos, la verdad, son simbólicos. Lo que estaban realmente probando son los marcos legales y realmente no pagaron mucho a las empresas, ¿ya? Pero ¿cuáles son los verdaderos mercados que se van a necesitar en la Luna? Y entre ellos les voy a mostrar 2, los mercados que se identificaron. El primero es de construcción e infraestructura, porque obviamente en la Luna se van a construir campos, bases permanentes y se necesitan materiales de construcción de la Luna. Al mismo tiempo van a haber hábitats para humanos, para astronautas, lo que son los pads para alunizar y para los despegadores, y al mismo tiempo todos los servicios. O sea, la Luna va a necesitar todos los servicios, transporte, energía, comunicación, etc. Y el segundo mercado es el de propulsor o combustible a base de hidrógeno, porque obviamente vamos a necesitar reabastecer todos los cohetes, vamos a necesitar reabastecer los alunizadores, los hoppers, van a haber estaciones espaciales orbitando la Luna, los cuales van a necesitar reabastecer de combustible hecho en la Luna. Y al mismo tiempo van a haber todo tipo de vehículos lunares y entre ellos Toyota está trabajando, yo creo que en el vehículo lunar más grande hasta este momento. Y bueno, pero como lo vimos en el estudio de PwC, hay que empezar con la parte de combustible a base de hidrógeno. Y muy bien, me gustaría terminar con una frase. Y la frase es: no conquistemos la Luna, construyámosla juntos para el beneficio de la humanidad. Hay que cambiar ese switch. ¿Bien? Pero antes de terminar, ¿cuándo va a ser que Chile va a crear su primer marco legal para que entidades chilenas puedan trabajar comercialmente con recursos espaciales? Y con eso termino. Muchas gracias. Muy bien, vamos a tener la oportunidad de hacer preguntas, 20 minutos en el panel al final de las presentaciones, pero nuestra siguiente presentación va a ser de Off-World. Nada más denme un segundo. Ya tenemos a Jim en línea. ¿Sí? Pero bueno, lo voy a presentar. Jim, can you hear me? Perfect.
Yes.
Okay, I'm going to make a quick introduction, just a second, but thank you, Jim. So, Jim Keravala, el cual ven en la pantalla, es el CEO de Off-World de Estados Unidos, quien presentará el tema de Artificial Intelligence in Mining, The New Paradigm. Jim lidera una de las compañías más innovadoras en robótica autónoma, aplicada tanto en minería terrestre como en minería espacial. Y su visión integra la inteligencia artificial, automatización y la exploración planetaria. Thank you, Jim. The floor is all yours.
Thank you, Carlos. Greetings, everyone. I hope you can hear me okay. And it's a real pleasure to be participating. And Carlos, you're a hard act to follow, as well as Angel. It's very nice to see you. So, what I want to talk about briefly over the next 10 minutes or so, I'll try and keep it quick, is just about the general applications of artificial intelligence in mining, but also the context of why we're doing that. Why is it specifically important? and why we can't just scale in the same way that we've scaled mining for the last 150 years. So really, the challenges that we have as a civilization are quite extraordinary. And if you can, hopefully you can see the screen okay, coming through. But as Carlos and Angel both alluded to, we are at a critical moment in history and in our future. In fact, we may be the pivotal generation. As Carlos was talking about the explorations to the New World in the 16th and 17th and 18th centuries, we are really entering the exploration and the movement to a new world now. And the challenge with that is it's really hard to do that with people going out into space to try and build infrastructure with an astronaut in a suit and then having holding tools or controlling tools directly. In order to really scale, in order to really build out the future, we need autonomy. And we need autonomy to an extent that we haven't even considered it before in terrestrial mining. But how do you get from here to there? How do we create that civilization leap into the solar system, starting here from the ground and building that experience to scale? Well, one example is what my company is doing at Offworld. The objectives of what we're doing is to take machine intelligence and sensing and embed that into autonomy and robotics in such a way that you do not need humans in the loop for the dangerous tasks, for the physical labor, for the high risk roles and activities that are required to do. And it's essential that we make these changes with machine intelligence, not just for greater profitability, but because the demands of our civilization's growth are putting such a pressure on the world around us, whether we agree or not about the impacts of the growth of our civilization, the demands on metal and mineral in the years to come are going to be significant. We are looking already terrestrially, just in the next couple of decades, at increased demand of critical minerals that would place our environment at such risk were we to mine that mineral conventionally. If we just carry on business as usual, the challenges that we will face and the impacts that we will incur will be of our own making. We will push ourselves over the climate cliff, trying to open up hundreds of new mines, digging up thousands of tons of mineral across millions or tens of millions of tons of ore, just to build the systems that should allow us to use less hydrocarbons. It is a fallacy of our long-term civilization planning that we can do this conventionally. So if we're going to have to figure out new ways to undertake machine intelligent operations, we really need to figure out many different ways of how we are going to do mining in the future. And some of the critical challenges we face really open up extraordinary opportunities with machine intelligence, with artificial intelligence, and integrated sensing, and then taking all those capabilities directly to the most dangerous points of the mining process where you can then use them in real time to increase your data and information and decision-making capabilities. So we can use machine intelligence in exploration and resource estimation. And we are trying to use this today across the industry for data analysis across geological characteristics to predict how the mine will increase its operations, its productivity, its profitability, and to utilize far-field remote sensing imagery, integrating imaging from satellites with ground sensor data for calibration can create greater confidence of information, greater confidence of mineral reserves and planning. And we can take that that information for mine planning and design to help optimize algorithms, to help build mine layouts, scheduling, improve hauler planning and route planning, and use that to increase digital twin development as well. By integrating the sensory data at the start of the rock face extraction, taking that along the development path of mining and operations, we can create digital twins with AI optimization across that entire mine planning process, which will enable us to undertake real-time autonomous decision making support so that we can have AI agents in the mining supply chain, in the mining process chain itself, optimizing mine development and mine architecture. And then the real benefits where Offworld is really developing further activities is to then take this intelligence and the applications of that autonomy and place it into robotics and vehicles and systems so that we can have end-to-end material handling, extraction, supply chain, and processing, and then take that to refining and processing the material as well so that we can control the optimization of which batches of ore get crushed at which rates. We can regulate the grinding, the flotation, leaching and smelting processes, and create increasing autonomy across all of this. And using image recognition systems, for example, in the sorting facilities, we can use computer vision to identify and separate the ore from waste, both optically and with other sensing capabilities. And again, the real advantage of all of this is that we can bring what is currently a very siloed, very isolated industry in terms of information management and data handling, and bring that together in terms of increased capability to allow the information silos to break down and create a unified data architecture and structure to allow optimization to occur in multiple places at a systems level. This is the real exciting opportunity. And what's so tremendous about this is that there's so much low-hanging fruit. There is, even with efforts undertaken by many mining companies today, we are still scratching at the surface of what is possible. We're optimizing existing processes, adding autonomy to existing vehicles, sensing existing material handling pathways. The real opportunity for machine intelligence is to put multiple levels of collaborative intelligence, embed them in robots and systems that undertake different tasks and activities of end-to-end capability. And this is what we're doing at Offworld. Our objectives at Offworld are to put autonomy right at the rock face, break the rock with robotics, use energy to get inside the rock rather than physical structures, and then have an end-to-end supply chain of vehicles and systems and sensing and intelligence that allow us to create not just the mine of the future, but the mine of the solar system. With autonomous excavation, intelligence, sensing, and then energy beam deposition, we can separate ions of metal as close as we can to the original location. And just instead of moving millions of tons of ore out of a rock, a mine every year, we're moving hundreds of kilograms of metals in treasure bots. And that's our objective, is to embed this intelligence into this capability that will allow us to take our hands off the joysticks or the wheels or the control panels and allow the robots to do the tough jobs. This is one of our excavators operating in platinum mine in South Africa. And this is using closed loop sensing, force feedback functions, optical ore body recognition. And these were early stage experiments, both with machine learning and with much more path planning put in place, but none of it with direct human control. So all of the operations that you see were completely autonomous. And this was really one of the world's first examples of pure autonomy in underground mining. And the advantages of bringing AI and robotics into mining are literally to break through on the economics, to increase safety, to enable a huge environmental impact, and also to revitalize local communities. One of the biggest concerns and fears I hear all the time is, well, surely if we bring more robotics and autonomy, this is going to disrupt our community's jobs. This could not be further from the truth. Our young men and women in the late 20s and 30s will increasingly not want to go into mine operations. They will not want to go deep into the mine body itself. What they'll want to get on and do is 21st century intelligence robotic mining, where the future is the fourth industrial revolution for learning in intelligence, machine learning, robotics, electronics, sensing, and systems that can be applied for many different applications. And we're taking all of that promise and capability and embedding in our first species that we're deploying is a multi-payload, all-terrain rugged surveyor system. The surveyor can take many different types of sensors, and it can go in locations that human personnel just cannot go. And this will allow us to go into post-blast sites. And one of the real benefits of machine learning optimization and taking artificial intelligence is not just which sensors you can put it in, it's having the right data captured at the right moment, distilled via the optimum intelligence into the right information, and handed over as making actionable intelligence to the decision makers. And by the end of 2025, we'll be rolling out our hyperspectral and LIBS equipped surveyors and bringing a GPR payload by mid-26 as well. And with the data fusion platform that we now have, we'll be able to accelerate exploration by many multiples in between first remote sensing data inference and then core drilling for exploration. We can accelerate and optimize the core drilling decisions and even drop lib sensors down the core holes for immediate full elemental data analysis. That leap in mining exploration intelligence that is coming in real time in mining exploration operations over the next 12 to 24 months is the direct precursor to where we want to go in the 30s as we head out to the moon. The moon is, as Carlos and Angel explained, is rich in resources and opportunity. We've been developing optimization experiments for extracting water from regolith simulant and then actually condensing to capture the first drops from an experimental perspective. And the idea being that we then take these capabilities and all of that machine learning, all of that intelligence learning that we've undertaken through our terrestrial operations, which will be ongoing, and then build on the production lines that our terrestrial robots are coming out on, the first lunar swarm robotic mining systems in the early 30s. And the idea is that we can then scale with full autonomy, with robust machine-informed robots that have already had millions of hours, robot hours of operations on this first planet. And then we can go to the moon as a second celestial body. If, as a community, we get this right, it's a big vision and it's a big mission, but it is an essential one for our generation to undertake. We do not know whether the next generation has the bandwidth, whether we have the resources, the economy, or the geopolitical stability to make this grand leap. But if we get this right, we can expand to the moon, into the solar system, and have a flourishing future for generations to come. That's why Lunar ISRU is the pivotal objective for this generation. With that, thank you very much.
Thank you, Jim, for the really good presentation. And thank you for sharing all these technology developments, not only for Earth and for space. And yeah, just like in the previous presentations, as all these presenters were sharing, I think we're pretty sure that if not all of the operations and all the activities, but maybe all of it will be fully autonomous at some point. So congratulations, Jim, for leading the way on the field of robotics, AI, and automation. Thank you, Jim. And please stay for the panel at the end. I'm sure people in the public will have some interesting questions for you.
Pleasure.
Muy bien, pues con esto fue la presentación muy interesante de Jim y como lo mencionaron los otros presentadores, básicamente creo que está claro que si no es que toda la parte operacional de las minas o el 100% de ellas al final van a ser autónomas, va a haber inteligencia artificial y va a ser robótica al final. No solo en la Tierra, sino en el espacio. Y Offworld y Jim son líderes en ese tema de robótica. Muy bien, con esto vamos a pasar con nuestro siguiente presentador, el cual viene de iSpace. Y nuestro presentador es Marshall Hall, su posición es el US Government Relations Lead de iSpace de Estados Unidos, quien nos va a presentar el siguiente tema, From Earth to Moon, iSpace's Journey in Lunar Exploration and Resource Utilization. Marshall lidera las relaciones gubernamentales de iSpace de Estados Unidos y ha estado involucrado en el avance de misiones lunares comerciales enfocadas en servicios de transporte y operaciones en la superficie lunar. Por favor, démosle la bienvenida con un aplauso.
Gracias, Carlos. And buenas tardes. I apologize. I'm going to be presenting in English, so I'm looking forward to next year returning and presenting in Spanish after some intensive classes. So my name is Marshall Hawley. I lead U.S. government relations for iSpace. And we've heard of iSpace a few different times. I kind of wanted to focus, give some overview of the company and understand what it is that we're so passionate about here. I want to thank Carlos and Angel, of course, for an excellent presentation about the importance of space resources and why it is important that we continue to go to the moon. I think the two themes that I'd like you all to take away from are two concepts, and the first is momentum. that for decades, the moon was untouched by exploration since the end of the Apollo program. And as Carlos mentioned, we're seeing a flurry of activity. Just this year, iSpace was one of 3 landers to be simultaneous en route to the moon. So there's tremendous momentum behind this. The world is engaging in this, and I think it is important for governments and industry across the world to really find their place to be part of this next grand adventure. And the second concept I'd like to leave you with is commitment. In iSpace, we are committed to engaging emerging space nations and other countries. We're all going here together, and we do not want to see the United States and others be the only countries on the moon. We want to see the entire world represented on the moon. Here's just a disclaimer. So what is iSpace? So iSpace's vision is expand our planet, expand our future. We envision a world in which thousands of people are living and working on the surface of the moon, and that moon creates this that creates an Earth-Moon ecosystem, leading to greater prosperity for both bodies. We use this thought experiment we call Moon Valley 2040, and we say, what would it be like for 1,000 people to be living and working on the moon in 2040, and what is the vision that and the policies and the technologies you would have to develop to make that happen? As Carlos and Angel mentioned, there are lots of resources on the moon, ranging from rare earth elements to uranium, but we really think that water really is the key here. And again, as Angel mentioned, we can take this water, refine it, once extracted from the moon, into rocket fuel, into drinking water, and into oxygen as well. And by taking advantage of the lower gravity of the moon, we're actually able to increase the amount of water we can put into these propellant depots around cislunar space, and eventually enable future exploration to Mars at much cheaper costs. So iSpace is a publicly traded lunar exploration company. We are based in Tokyo, Japan. We have around 315 nationalities and major presence in Tokyo, of course. We have a North America office in Denver, Colorado, with around 100 employees, and around 30 employees in Luxembourg, where a lot of our ISRU work is focused on. We are publicly traded. We have around $400 million of total investment, and we have around 300 employees. And I'd like to point out this nationalities. We have over 30 nationalities from across the world that are working for us. So even when you visit the iSpace headquarters in Tokyo, over 50% of our staff in Japan are not Japanese. They're from all across the world. Name a country, they will be there. From Turkey, from Brazil, from Australia, they're across the world. And I think this really represents why lunar exploration is so interesting. I like to say that the world's loss is our gain, that we're able to go and recruit the best engineers from across the world that want to work on these very interesting problems. And I see it's important for countries like Chile to have these exploration programs in order to keep talent local. How great would it be if you could work on these very interesting problems in Santiago and not have to travel to Japan and work in Japan for several years, as amazing as Japan is. So iSpace comes out of a program called the Google Lunar X Prize. So this was started by Google, as the name says, and it was what company can privately land on the moon, a rover on the moon, and travel 100 meters returning video. Unfortunately, the prize was never claimed, but from that, iSpace and a lot of other interesting companies, such as SpaceIL, the Israeli company, emerged from this. And we quickly realized that it wasn't enough to build a rover. We have to develop a lunar lander. So we started development of our M1 lander program, which launched in 2022, was the first commercial lunar lander en route to the moon. And over the subsequent years, we started operations in the United States and Luxembourg and raised the largest ever Japanese Series A in history. In the United States, we work with a partner, Draper, for NASA Commercial Lunar Payload Services, or CLPS teams. And our service is quite simple. We use SpaceX or another vendor to take us to lunar orbit. Our lander performs a low-energy transfer, and we land you on the moon and deploy a rover and provide communications back to Earth. Pretty simple diagram. Our business model has 3 services. We have our payload services. We have our data services. This is collecting mission data about the composition of minerals of the moon and the technology development on the moon. And then we have a partnership service. This is similar to a sponsorship. So we partner with large brands. You see the logo for Japanese Airlines or Suzuki. We put their logo on our lander. When you actually go to Japan, the iSpace mission is in the screen of the taxi cab. So as you're driving around, you see the lander landing. And we're developing a robust lunar lander program. So we have a micro rover, which we're developing with iSpace Luxembourg, what we call a resilience lander, which we're developing in iSpace with iSpace Japan. In the United States, we're working on something we call the Apex 1.0 lander. And in Japan, we're also working on what we call Series 3. So these two landers have about 15 times the payload capacity of this lander. Resilience can take around 30 kilograms to the surface of the moon, so not that much. So when you talk about this importance for having a high price point, 1.5 million, for example, per kilogram, we believe that we need to size up our vehicles in order to gain cost savings for the commercial market. In Luxembourg, where we develop our planetary mobility suite, we have a series of rovers, such as the micro rover, which can take around 1 kilogram of payload, the Explorer rover or X rover, which can evolve to around 20 kilograms of payload. And eventually we'll be designing what we call Lunar M rover. This is a bit more notional at the moment, but we see this as having a tremendously large payload capacity and range compared to these other two micro rovers, which are the size of maybe a few shoeboxes stacked together. So as I mentioned, we were the first commercial lunar lander to attempt landing on the moon in 2022. We currently have a lander en route to the moon as we speak right now, which will be landing in June 5th of this year. So it'll actually be, this is Eastern time, so 3:30 p.m. June 5th here. So please sure to watch it live. In Japan, we are further developing our Series 3 product line. In the US, we're developing what we call the Apex lander, which is aimed at the NASA customer. And then in Europe, we have the Tenacious rover, which will be the first commercial lunar rover deployed on the moon, hopefully here in June. So our first mission was 2022, 2023, and we got extremely close. So we had 10 success criteria. We completed what we'd say 8.9% of all the success criteria, and it was really in the last final moments of the landing that we had, unfortunately, an anomaly, and we're not able to complete soft landing. However, we learned a tremendous amount from this experience, and we've fed all those lessons back into Mission 2, which will be, again, is en route to the moon right now for a June 5th landing. So you see we launched with SpaceX, we reached the final lunar landing phase, and we achieved a lot of very useful lunar data that's allowing us to have a more successful missions moving forward. But Mission 2, this will be the first commercial lunar rover deployment for Mission 2. As Carlos mentioned, we have developed a lunar rover in Luxembourg that has a scoop that will manipulate regolith. We've worked this in partnership with a company you may have heard of, a Swedish company called Epiroc, which is a Swedish mining company. And when we collect that regolith, we're going to sell that to NASA in the first, as Carlos mentioned, the first extraterrestrial resource transaction in history. We're not taking it back. It's just going to stay there, but NASA is welcome to come get it if they would like their regolith. We will also collect some regolith on the lander itself and sell that under Japanese lunar law. Our primary payload is a water splitting experiment from a company called Takasago Thermal Engineering. We've heard a lot about ISRU and the importance of in situ resource utilization. Takasago Thermal Engineering has developed a payload which will test electrolyzing water into hydrogen and oxygen. This is Earth water taken from Earth, but will be the first lunar ISRU experiment in history. We also have a lunar algae cultivation experiment, and then a series of other payloads, including a space sentry plate from a popular company called Bandai Namco, which is a popular media company in Japan. We even have artwork. So this rover will deploy a little house on the moon, and we'll take an image of it. It will be a piece of interesting lunar art. Here you see, again, I mentioned a major theme of this is momentum, and this is no longer the realm of science fiction, that this is actually happening. So you see the development of our M2 mission. You see the rover is here in the payload bay. This takes place at the JAXA facility, the Japanese Space Agency facility, and Tsukuba. The rover deploys out of here. Here's our Tenacious rover with our little scoop on the front. So with the gold covering is MLI. This is the thermal insulation for the rover. And we are currently have completed up to Success 5. So we've completed our launch preparations, we've completed launch and deployment, we have a steady state operations, we've completed lunar flyby, and very soon, hopefully in the next few days, we will complete all of our deep space orbital control maneuvers before LOI. And then hopefully we will enter lunar orbit and then land. So here you see, this is the lander that's folded up before it's integrated in with the Falcon 9 from SpaceX. We actually launched with Firefly Blue Ghost. It was a 2-for-1 lunar lander mission. Here you see the lander is being deployed from the SpaceX Falcon 9. And everyone's cheering on mission control. This is the best feeling, of course. And a real image that we took of the Earth from Earth. You notice there's no land, and this is because this is Point Nemo. So this is just to the west of Chile. This is the point of Earth where there's furthest from any land. So in fact, when the International Space Station will eventually be deorbited, this is where it will be aimed at in order to prevent any possible impact from impacts on Earth. We take a bit of a slower path to the moon. We use what's called a low energy transfer. So we go actually 5 times further than the moon, 5 times Earth-Moon distance before we swing back around. And this allows us to save fuel, but it means it takes a very long time. So we launched in January, we will land in June, mission life of about 5 to 6 months. Our future missions will go direct to the moon, will take only a few weeks. And this is a photo that we took, a real photo of the moon, that we took on lunar flyby. So hopefully we'll get much closer here in the next few weeks. We are landing, Angel talked a lot about the different types of terrain on the moon. We're landing in the Mare Frigoris. This is a very flat landing spot, and we hope to do some really interesting science once we land. And as we mentioned, we'll be deploying what we call Tenacious, our lunar surface venture. This deploys out of the lander. It will acquire regolith and demonstrate our first series of ice-based planetary mobility maneuvers. And then moving forward, we already have future missions manifested. So this is launching in Q4 of 2026, the Apex 1.0 lander. Our primary customer is NASA. We have a series of around 100 kilograms of NASA payloads, but we have a series of commercial payloads as well, both from companies in the United States, from Romania, and from Italy as well. This will go to the far side of the moon. Not only the far side of the moon, but the far side south pole of the moon. There's currently no relay satellite capability, so we are developing and we are deploying 2 relay satellites in lunar orbit, which will be there for 3 to 5 years to allow us to land on the far side of the moon. It's a very challenging mission, but we're very excited for it. And then finally, we have mission 4, which we're projecting also in the 2027 timeframe. This is funded through an SBIR grant through the Japanese government. This is intended for the international lunar market. So whereas the Apex 1.0 lander is specifically designed with the United States in mind, with the US supply chain, this is designed for the international market. So one last photograph to leave you with. Never quit the lunar quest. When our first mission was not successful, but we realized we had to be resilient, we had to move forward. The message for you all is that this is happening and it's important to be a part of it. We are here to find strategic partnerships opportunities. So we would like to collaborate with government, with industry, with academia to find what is the best way that we can get Chile involved in these really interesting lunar exploration missions that are occurring over the next few years. Thank you very much for your time and looking forward to your questions.
Thank you so much, Marshall. That was a really, really good and interesting presentation. And I would like to make a few points. The first one is iSpace, in a way, is a company that is building the space galleons, right? Going to the moon. And the other one, as we saw before, the only entity that has landed on the far side of the moon has been China, the China Space Agency. And if iSpace is successful, they will be the second entity to land on the far side of the moon. So the best of lucks, Martial and iSpace, and we're going to be crossing fingers for your landing attempt on the 5th of June, correct? Perfect. Thank you. Muy bien. Bueno, estaba mencionando rápidamente que iSpace de alguna forma es una de las compañías que está construyendo galeones, pero espaciales. Y también, si aterrizan exitosamente en su tercera misión, van a ser la segunda entidad en el mundo de aterrizar en la cara oculta de la Luna. Sí, la pregunta es de quién sería la reina Isabel espacial, pero ya platicaremos sobre eso. Exactamente. Muy bien, pues vamos a pasar a nuestra siguiente presentación, la cual es la doctora Catherine Hadler. Es la directora del European Space Resources Innovation Center, o ESRIC, y nos va a hablar sobre este centro de investigación. Y el tema es ESRIC, the Center for Space Resources in Europe. Y ESRIC se ha convertido en un nodo central para la innovación, investigación y colaboración en recursos espaciales desde Luxemburgo. Catherine, thank you so much for joining us. And can you hear us well there?
I can hear you. Sorry, I'm just trying to multitask. I can hear you perfectly, Carlos.
Perfect. Thank you so much again, and the floor is yours.
Thank you so much. Thanks, Carlos, and thank you to the organisers for inviting me to speak at this event. Good afternoon. So my name is Catherine Hadler, and I'm the director of the European Space Resources Innovation Centre, which is based in Luxembourg. We've already heard from the previous speakers about Luxembourg's role in space resources, and also some of the really inspirational activities that are ongoing at the moment. What I'm going to talk about in the next 15 minutes is what we are doing in ESRIC, what ESRIC is, what we do, and where the role of terrestrial mining and mineral processing comes in. So Carlos gave a really beautiful introduction to his career. Here's my introduction. In a second, please. I do not come from the space sector at all. I actually am a research academic from the mineral processing sector. So my background is in flotation, and I expect there's a few of you in the audience that might know, might be familiar with this kind of scene. So this is what I come from. I come from flotation, from carrying buckets on processing plants into space resources. But actually, there's a really big need and a big role in space resources for the terrestrial mining expertise. Jim already gave a talk, very inspirational talk about the world of the work of Off-World. But the role of mining in space resources is critical, and we will see that shortly. So from flotation into space resources, ESRIC is a research and innovation centre that is entirely dedicated to space resources. It was launched in 2020, so it's coming up for its 5th anniversary later on this year. It was launched as an initiative of the Luxembourg Space Agency and the Luxembourg Institute of Science and Technology, and we work in partnership with the European Space Agency. We have a very clear mission, and our mission is to be a world-leading centre of excellence in the science, technology and business of space resources to support human and robotic space exploration and the future in space economy. So that is our mission as ESRIC. Like I say, we are coming up for being 5 years old, and we currently are a team of 30 people working across the domains that we will see shortly. Our activities fall into 3 clear pillars. So we have research. We do our own research. I have a team of researchers from PhD through to postdoctoral, through to experienced researchers. But we're also developing R&D facilities and capabilities for the community to use. We support the growing commercial activity in this field. We've heard already about some of the commercial activity, but we support this dynamic sector through our incubator and business accelerator schemes, both in partnership with the European Space Agency, and I will talk about those shortly. And in addition, our final pillar is to support the community. There is a really wonderful, dynamic, energetic community around space resources. We host several events and activities to bring that community together. In terms of our research activities, we'll start with research. Let's start with research. In terms of our activities, one of the wonderful things about space resources is it is incredibly broad as an activity. And so we do a lot of research in various fields along the lunar oxygen value chain. So we're primarily interested in lunar resources at ESRIC. This is because we are new and we need to start and focus somewhere. So we're interested in lunar resources, and much of our research is focused on the lunar oxygen value chain, through from beneficiation into extraction of oxygen, use of metals, metal byproducts, purification of water and oxygen, and then through into other activities, construction using regolith, and then additionally operating in a dusty environment, the challenges of working in this extreme environment. On this map of activities, you can see some of our projects and our partners. So you see that we are funded by the Luxembourg National Research Fund. We have projects with ESA and with companies such as Airbus and Air Liquide. Here we see a more logical flow, if you like. So here we have the lunar oxygen value chain and the research that we do. So in terms of prospecting, understanding resources, we look at resource mapping and prospecting strategy. In beneficiation, this is my field, then we look at size classification in addition to concentration of interesting minerals such as ilmenite. Then in oxygen and metals production, we look at reduction by hydrogen, plasma enhanced reduction, and molten salt electrolysis. And then we go through into construction using microwave sintering and purification of water. Currently we use adsorption, but also looking at other technologies as well. We're interested more broadly as well in the concepts around space resources, taking lessons from Earth. So how do we minimize the footprint of such operations? How can we enable that all product streams are used? And this relates to the project we have with metal byproduct use. How can we operate in dusty environments? A lot of these have application on Earth as well. And again, in more detail, because it's not always obvious what we do in the research domain in this field, we can look specifically at hydrogen reduction or reduction by hydrogen to extract oxygen from lunar regolith, specifically targeting the ilmenite in lunar regolith. The type of research that we can do in this sector is, for the fundamental level, we can look, for example, at plasma enhanced reduction of iron oxide. We can build prototypes to test these these fundamental science concepts at a larger scale, and then we also do system level scientific studies. So the system that you see on the right here, the system level, this is a 1.4 kilo hydrogen reduction system that was procured by the European Space Agency and is operated by ESRIC. And that gives us a sense of how we build these end-to-end systems, how we can operate them and optimize them on Earth, and therefore how we might do this in space. But as many of you will be familiar, we need to be able to recover the resource. And I think this is something where the terrestrial expertise really is critical. We talk a lot about resources and reserves in the space resources sector. It's quite an interesting concept because in many respects we know very little. But for a resource to be reserved, we often say it needs to be recoverable. But for that, we need to know more about the deposit, and we also need to know about the operating ranges of any particular technologies. So here's an example. I am not going to go into details here, but the example here, this is a desk-based study. So it's paper-based. It is not an experiment that was done. And the reason that I showed this study is because it shows the impact of beneficiation on the reactor size. So here we're looking at reactor size and mining rate to produce a given target of oxygen from lunar regolith. In this case, we're looking at 1,000 kilos a year of oxygen production from lunar regolith. And the reason we did this study was to illustrate the impact of beneficiation. So if we concentrate the ilmenite, then we will have a smaller reactor, which is great because then we have a lower energy consumption. But in order to achieve the same target mining rate, same target oxygen production, then we need to have a higher mining rate. Now, this is important because if we are looking at providing excavators, then we need to know how many excavators, how they will be arranged, what's the excavation rate, where's the trade-off between the number of excavators and the energy consumption of the reactor. Now, for us on Earth, this is quite different because we have targets. We know on a copper processing plant broadly what target copper content we are chasing. With space, we don't have these constraints. We are constrained by the environment, but we don't have targets. We are looking at the ideal trade-off between energy, hardware, landed mass, and production rates. And that gives us a whole different set of constraints to think about and allows us to think differently about the mining process itself. And for me, this is one of the most exciting things about space resources, is rethinking the processes by which we extract and use resources in a different context. And again, just to continue this theme, we can now go into exploration, prospecting, and look at what we know about those ilmenite deposits. So on one hand, we know that there's an impact of beneficiation on the reactor size and the excavation rate. And now we can go back into the available data from the from remote sensing. So what do we know about these ilmenite deposits? How were they formed, and how might that impact the form of the ilmenite and how we might process it in the future? And together, that allows us to bring together the prospecting and the processing. Now, in the terrestrial mining sector, there are a lot of different stages to this. We have the exploration geos, the mining people, and the mineral processing people. Now, the mineral processors don't always talk to the mining people, who don't always talk to the exploration geos. One of the great concepts here with space resources is that we can bring together, we have to bring together all of these different disciplines in order to be able to design these systems to work effectively and with minimum impact to the environment on the moon. So that gives you a sense of some of the research we do at ESRIC, but just to continue with some of the other activities, I said that we're developing facilities and capabilities for the community, for our labs and our community. And there's two on the right-hand side, you can see two facilities here that we are developing in partnership with the European Space Agency. One of them is a large dusty thermal vacuum chamber. So this will be a 2.2 meter diameter vacuum chamber filled with or with a layer of lunar stimulant that will allow companies to come and test in a relevant environment to increase TRL and to test for future use on the moon. On the other one, the ground-based pilot plant, this is an oxygen from regolith-based, regolith the lunar dust-based pilot plant facility that we are currently developing for the future, again, for industry, for partners, for researchers to come in and test their technology in a system, to test it as part of an end-to-end operating system. In terms of our commercialization activities, we run a business incubator and an accelerator program. The incubator program, the startup support program, is run with the European Space Agency. It's the world's first business incubator entirely dedicated to space resources, and it is open to anyone from around the world. So any startup with a space resources related activity is welcome to participate in the incubator. From each cohort, from each call that we have, we select around 5 startups to undergo a 12-week remote pre-incubation, so business coaching, business plan development. And from those 5 pre-incubated companies, we select generally 1 to be incubated fully in Luxembourg. That's been running now for about 3 years, and we're up to the 5th cohort. It was joined in 2024 by the Accelerator program. The Accelerator is for the next stage along. So this is for the business scale-ups who've already demonstrated that they can, that they have raised external funds to support their activities. And this is based on again, the Accelerator program is based on a 50-50 co-funding model. So 50% coming from the European Space Agency and 50% supplied by the company themselves. And we as ESRIC provide the operation and any technical support that we may be able to offer to these companies. For our community activities, just the final couple of slides, with the European Space Agency, we run a Space Resources Challenge. We're up to our 2nd challenge. The first challenge was hosted in 2022. It was a prospecting challenge. We filled a large concert venue with basalt and then set 5 companies or five teams off to remotely prospect that basalt to find the ilmenite. It was quite a large spectacle, as you can see on those top photos. And now we run the exercise again, this time using the European Astronaut Centre's facility. We're looking at excavation and beneficiation in our current challenge. This is only open to European Space Agency member states, but it has been a really interesting exercise in driving innovation through the use of challenges. And then our final activity is Space Resources Week. This is the largest gathering of the space resources community in the world. Angel probably mentioned Space Resources Roundtable in Colorado. The Colorado and the Luxembourg events are very much the two key events in the calendar for our community. Our event in Luxembourg is the 19th to 21st of May, so in just about a month's time. There is also online participation, so you can watch online if you are not able to come along to Luxembourg to join the fun. My last point is that just to round off the story, we often see this picture of an astronaut covered in dust once he's been on the moon. And if we go back to my picture, this is from Red Dog, which is now closed up in Alaska. There's not that much difference, I like to say, between mining on Earth and operating on the surface of the moon. And we, as mineral processors and miners, have a lot to offer to this sector. And in return, there is a lot that we can learn from thinking about the way in which we extract resources differently. Thank you very much.
Thank you so much, Catherine, for the really good presentation. And I think you just proved that mineral processing engineers have passed the first test for astronaut training on how to withstand dust. Very good. But first of all, thank you and congratulations for all the work that you guys have done, because ESRIC was only created in 2020. And it is really amazing to see all the work you've done around research, technology development, and very important supporting startups. So thank you again, Catherine. And in Luxembourg, it's quite late, so she might not be able to join us on the panel. However, I might be able to make you just a quick question before we let you go, Catherine. And the question is, maybe what type of collaboration do you see that someone like ESRIC can have with research centers or universities in Chile, like the University of Chile?
That's a great question. Yeah, we, as a research and innovation centre in a research and technology organisation, then we are always interested in looking for collaborations. So in terms of research visits, supporting master's projects, but also for looking for international collaboration, I think we would be really interested to see what we can make happen. But international collaboration, absolutely, we are always very interested in that, Esric.
Perfect. So this is clearly an invitation for the University of Chile and other universities to get in contact with Catherine, with Esric, and yeah, make some magic happen. But Catherine, thank you so much once again. And
thank you very much.
And we'll see you at Space Resources Week in May. Thank you for the invitation.
Absolutely. Thank you.
Muy bien, con esto vamos a pasar a nuestra última presentación antes de ir al almuerzo. Y vamos a cerrar con el profesor Serkan Seydam, que es el subdirector del Australian Centre for Space Engineering Research en la Universidad de New South Wales. Y su presentación es Space Resources Activity in Australia and its relationship with the mining companies. Y esta va a explorar cómo Australia, con su fuerte industria minera, igual como Chile, está integrando capacidades para liderar también en el desarrollo de recursos fuera del planeta. Welcome, Serkan, and the floor is yours. Thanks.
Thank you very much, Carlos. Thanks for the invite. And so it's about 4:15 a.m. in Sydney. So I arrived yesterday. Please excuse if I do any mistakes. I'm struggling a bit to be very away, but I had maybe 4 or 5 coffees already. And so I know we are pressed with the time, so I will try to be quicker than expected. So what you see here is our CubeSat. So if you can click the video, I don't think I can click the video here. Yeah, yeah, it's working. So this is the simulation of our CubeSat currently in the space, developed by UNSW and our center, AXA. And so a bit of myself, Carlos said a couple of things. I'm a very much mining engineer. All of my degrees are from mining engineer. But I'm work on deputy director of Space Center in UNSW, which I have a couple of hats. I'm also chair of mining engineering at the School of Minerals and Energy Resource Engineering. I'm here in Chile because of also attending Expo Min starting tomorrow. So quickly about our school, we are ranked in the in global ranking number 2 in the world. So number 1 is, I'm not sure Angel is here still, number 1 is Colorado School of Mines, as you may know that. So we are also number 10 in the petroleum engineering, but we provide both undergraduate and postgraduate students about $20 million research income annually, and we got 300 plus students, postgraduate and undergraduate, plus 80 plus PhD students, which is quite a remarkable number for a small school. So Australian Centre for Space Engineering Research, we actually, I'm not going to go through all of it, but we built CubeSats, as I mentioned, as well as we lobbied for establishing the Australian Space Agency, which established in 2018, and also led lobbying of, and also invented off-Earth mining forums, which we started in 2013. Catherine mentioned that there are only 2 key events in space resources. One is in Colorado, other one is in Luxembourg. I would add off-Earth mining forum as well. I believe we are the first group that we established these events. So Angel can correct me if I'm wrong. So as I mentioned, Australian Space Agency is very new, established in 2018. And we are part of the NASA Artemis Accord. Also Angel mentioned in his speech. Now we are ready for space. So it's a little bit of fun, but you know, everyone knows how it works boomerang. So we are full on. But also we are known that in 2020, Hayabusa 2 mission completed and landed on Kupapidi in South Australia. So that was on the news as well. So Australia, I want to talk a little bit about capabilities of Australia. Australia most recently establishing for 2024 and 2025 budget more than $22 billion. I'm talking about Australian dollars, but the billion is too big anyway. There's no need to convert. And future made in Australia. So that's focusing, developing technologies and achieving net zero for the future. So space is actually a big part of it because Australia's space sector is really big, very big, skyrocketing with annual growth of more than 7%. So the industry is really aiming by 2030 to be $12 billion of industry. So the quite a bit impressive numbers. And in New South Wales government, actually, we are part of in New South Wales government supporting Future Made in Australia as well, with the space capabilities, space engineering capabilities. So looking at sectors in the space industry in our states, space systems, launch and support services, ground systems, space-enabled services and applications, R&D and education training through the universities and research organizations. But I add this last night, actually, because I just learned that from New South Wales government, which is very new. It's just been announced this week. New South Wales Trade Investment Strategy, which not been fully released yet, but MET sector will be, MET means mining, equipment, technology, and services, will be formally recognized as the priority export industry for New South Wales. Within this framework, space mining has emerged as a key area of strategic focus for the New South Wales government's industry development agenda. So I've been told by the New South Wales government to add this, actually very impressive, actually. I just learned last night, as I said. So the National Space Industry Development Hub actually established in New South Wales government through the Sakada Innovations will be very important central platform developed in New South Wales industry. So also New South Wales government co-hosting the International Astronautical Congress, ISC 2025. We're expecting 80,000 people to Sydney, arriving Sydney in September, starting in 29 September, which is my birthday actually. So we can celebrate with 80,000 people. So I'll talk about it a bit later on this. So I also wanted to include some of the Australian startups and SMEs in the sector, which is quite impressive. Some of them already been mentioned through Angel and others throughout today's presentation. So Fleet Space is actually quite growing. I mean, in 2013-14, they established like 2 people. Now they got more than 100 people working. Very similar story of iSpace actually. And Fleet is working on IoT technologies from space, but also performing in mining industry. And Gilmore Space is a launching company in Queensland, and HEO Robotics is actually a spin-off from UNSW PhD students. They studied in asteroid mining and established this company, very rapidly growing. They got more than 100 people as well. And SPE, Edge Computing Hardware for Space. Extraterrestrial Power is also a spin-off from UNSW, working on solar power systems. Saber Astronics, which is space mining mission design, very similar to ASRIC on incubators. And Fugro is actually an exploration company based in Western Australia, but they're working on space resource exploration as well. They established SPARC, most recently, Australian Space Automation and Robotics Control Complex in Perth. And Interlune is an American company, but also operating in Australia, working on extracting space resources from the moon. And extracting space resources, Queensland-based, and I think South Australia, could be South Australia as well, focusing on asteroid mining. So these are the companies. And on the right-hand side, I put other organizations. So EROS, which is, I can't see this. So which is Australian Resource so I can't read it, but EROS is actually a remote operation center, both operating for space and earth earth industries, and it's an NGO, and UNSW is a partner with EROS. Adelaide University, as you may see the difference, University of South Australia and University of Adelaide now merge under the Adelaide University. It's only one university now in South Australia. So they have Andy Thomas Center for Space Resources, and they providing a space resources training program. It's not accredited, it's not a master program yet. So CSIRO's ISRU facility working on lunar test beds and rapidly growing in that area. And QUT is actually Queensland University of Technology. They got recently a new space lab and lunar bed, which we collaborating with. They collaborate with UNSW. I'll talk about this a little bit later. So these are the all major capabilities of current Australian capabilities in space resources. In addition to that, Australian government created some more initiatives about worth of $9 million on 12 projects. So one of them, focusing on Moon to Mars initiative for Artemis program. So Valiant Space, a Queensland-based company, about $1 million developing non-toxic propulsion system. And Next Aero, Victoria-based, about $1 million funding for design and manufacture and validating cryogenic rocket propellants. HUI, as I said, UNSW background company, $700,000 to develop advanced cameras for imaging satellites. And Newman Space is South Australian company. They got about $1 million for developing spacecraft electric propulsion manufacturing technologies. In addition to that, and based on the Artemis program, to support NASA's Artemis program, Australian government developed Trailblazer program in 2021. So they initiated stage 1 projects, which went to EROS, about $4 million to develop a rover system, and also Zangold, about $2 million. But that was the first stage, and the second stage been announced recently, which is about $42 million on, I can't see it here anyway. So developing this rover. Rover is the official name of the Australian rover, will be landed on the moon. That's the most recent update on that. And then a little bit of UNSW marketing and what we're doing in this area. So as I said, we established Off-Earth Mining Forum in 2013. And we're not running this every year. We're trying to do it in every 2 years. So we run 6 of them so far, and the 7th one will be on 25th and 26th September this year. Just before the ISE, we want to use the opportunity people will come to Sydney already, and they can attend Off-Earth Mining Forum. Off-Earth Mining Forum only works with the invitation. So if you are interested, I know iSpace will be coming, Epiroc will be coming. And if you are interested to present, please let me know as soon as possible, because we're finalizing the program soon. So UNSW also developed 2 sets of software packages for NASA. First one was the water extraction Mars mining model, basically for linear programming for equipment selectivity. We developed together with Jet Propulsion Laboratory. And then second software was mining optimization and Mars mining operation optimizer. We developed this part of the SBIR US government funding together with Virginia Tech and Kennedy Space Center. They're all active software packages used by NASA right now. So what we're doing in UNSW, our ultimate aim to reduce the risk perceived by a potential investor in space resources venture. that's what our focus. So we develop a wild project for the moon resource engineering activities, but very much collaborative research. If you look at very multidisciplinary in engineering faculty, we collaborate almost every engineering discipline, as well as interfaculty in engineering science, business law, arts and human and built environment faculties in UNSW. And we collaborate with iSpace. We got a partnership agreement. We got partnership agreement with Epiroc, Interlun, Fleet Space, and Aeros. Also international partners, NASA Jet Propulsion Laboratory, Caltech, European Space Agency, Korean Institute of Civil and Tunneling, KICT, and the Japanese Geological Survey. So we are currently very international, and we keep adding the new partners on this. So we do a lot of collaboration, as I said. I'm not going to go through all of it. So we've been part of both NASA and European Space Agency projects, and we've been part of the advisor as an advisor of LORS 101 developed by Carlos in the past. And so the facilities, so these facilities are quite new, and so our focus is developing space supporting laboratories. On the right-hand side, you see the spacecraft innovation laboratories, more in the electrical engineering school as part of AXA, but also we're focusing most recently in extreme environment laboratories. So rock testing in environmental chamber, plus minus 200 degrees, we can test rocks, which is unique. We got only in our university, we develop ourselves this equipment, and micro CT, which exists for many universities, but virtual reality and hologram specifically used for the space activities. We have this only in our university, and we're working on the processing and also thermal vacuum chamber, but also dirty vacuum chamber. Catherine was talking about they will get it in ESRIC soon. We have it already, and this is the only equipment in Southern Hemisphere, as far as I know, and we will also have Munyar. So we are opening these facilities this month, actually. So we got also UNSW's vertically integrated projects. So all the engineering first and second year students working VIP projects. We got 2 projects under this scheme, MINEX and Off-World Robotics. So imagine that we got about 1,000 first-year students in engineering, so they're working in those 2 projects in group of 8. So it's quite a bit capacity. They develop ideas, and then they won first time in 3rd space in Over the Dusty Moon Challenge, Colorado School of Mines, and then year after they become number 2. So we are quite proud of it. And then I developed space resource engineering course. Carlos taught last year one part, and hopefully we'll do it next year as well. And this is not a program yet, but this is the course only in our master program. So I established part of International Society of Rock Mechanics and Rock Engineering. I established Commission on Planetary Rock Mechanics. As you see, our group's quite multidisciplinary and international, and we trying to create a new sub-discipline under the rock mechanics, because we know that planets, rocks being formed different than Earth and very extreme environments. So we're trying to understand how these rocks will behave, because it's very important for materials handling and mining activities, for space resources engineering activities. So PhDs are very important, big part of our work. So we got about 11 students, but 7 of them, I can say the 7th one graduate because just submitted. And so as far as I know, Jessica is world's first PhD graduated from mining engineering school in space resources topic. So she's currently working in New Zealand Space Agency as a space policy developer, senior space policy developer. We are all proud of our students, and we publish about more than 40 papers. So I put some of them here. So we're working in very different range of topics, as you see from the PhD topics. So we're working on the mining systems, extraction technologies, sustainability, and economics, and rover design, architectural design. So all these, so some of these students already established their spin-off companies and rapidly growing. So that was the current status of what's happening in Australia. I want to cover right now how the mining industry takes into this. So I'm not going to cover that. Angel and all others already talk about why we need, what's the motivation, and so the question is who is going to do it. But Carlos already talked about a little bit of history, but everyone is expecting space resources activities will be done by the major agencies, as all you may expect. But to me, if you look at the first flying man researcher, I would say, was in Hazarfen Çelebi in Istanbul in 1632, which he died in the tests. And then Montgolfier brothers in 1783, first hot air balloon carried humans. And then, of course, Wright brothers. And none of them funded by governments. None of them were government employees. So I believe we should consider these private entities, as we discussed, and some of the examples here, off-world and iSpace and others. So I want to really quickly go through the space industry's major achievements. Space exploration, satellites, spin-off technologies, Earth observation and climate science, international cooperation, inspiration, and developing space economy. These are the major industries, space industry's major achievements. If you look at what are the major factors dominating the space economy today, looking at all these telecoms, GPS, Earth observations, and also equipment like space vehicle, ground and space stations, and all the receivers and etc., as well as the agencies' development and satellites. These are the major factors dominating the space economy today. But spin-offs are very important too. Even the seats we're using currently in our cars, being first, it's a spin-off from the space seats, actually, space vehicle seats. So, I mean, I'm not going to name all of them, but really many spin-offs coming from the space industry in our daily life, we use in our daily life. But the future for space resources, I mean, previous speakers already covered, but I think the colonization and then crewed operations and reducing investors' risks and creating markets, perhaps first tourism and then mining, or first mining and then tourism, or together. And then space debris mitigation, zero waste operations, and then space-based energy systems, probably the upcoming future activities for the space resources industry. And then legal framework, ethical standards, Carlos already talked about. So if you look at the mining industry, so achievements, so we providing the raw materials for almost every industry, and then we develop the metallurgy and processing activities, and then we are the main reason of industrial revolution. So we name first, second, and third. I'm not sure we are in the industry 4.0 or not yet, because we will know that in 20, 30 years later. But energy production, as well as mining industry, develop first risk management practices, which every other industry is using right now. Looking at the major factors dominating the mining economy today, the commodity market, of course, supply, demand, and price changes and cost activities. Also, as Jim mentioned about environmental and social and governance, which is sort of new terminology for mining industry, replacing sustainability words, sustainable mining practices, which meaningful. All development of regulations for environment and sustainability, all infrastructure, risk management, and of course the skills. And also all these maths, mining equipment, technology services in really supporting most of the mining activities. I mean, Epiroc, one of them, iSpace, and also Carlos also mentioned that. And spin-off from mining industry is actually zero, because miners like to be first to be second. So you can't name, I'm teaching technology management course, which Carlos sit down in years ago on that course in master. I can't find any mining innovation done which we are currently using in other industries. So we don't have any spin-offs. That tells us something about the industry. So the industry's future of mining industry's future, I guess 3 things. Zero human entry. Zero entry mining. Jim already talked about that. Zero waste mining. Jim also talked about that. And zero emission. He didn't mention specifically, but I think is one of the outcome. So we need to issue these 3 zeros for the future, because it's very important. I'll come back to you later very quickly. So space and mining, superficially similar. The commonalities, they're both multinational. They have long life of operations. We are both operating in remote areas, in extreme environments, as well as with extreme risks and high cost and financing projects we have. The challenges, I'm not going to repeat, everyone already mentioned, and mostly Carlos talked about it. So all of these challenges is quite important. So Jim mentioned about this autonomy, automation, how much human intervention required, involvement required, which we couldn't really talk. But also managing the technology is a big challenge for both industries. And regulatory already been discussed by Carlos. So now very quickly, how the technology transfer can be achieved from space to mining. What are the drivers? What are the impediments? So the drivers from space to mining, spin-off success, as mentioned before. So social acceptance. Jim mentioned how bad in social acceptance in mining, so we can learn from space industry. And which reputation, experience in autonomous systems and robotics, knowledge and of navigation systems and communications, systems engineering approach. Mining industries right now is taking this from space industry, and potential to eliminate Earth's resource scarcity, and being good role model for international partnership and collaboration. Space is excellent on that. Failure is not an option approach, is very actively working in space, which mining we more try and error approach we have. And impediments of transfer from space to mining, lack of financial motivation, not fully commercialized industry yet, and high risks, skills shortage, lack of regulations, higher uncertainty, lack of accepted resource classification, lack of existing activities. As I mentioned, miners like to be first to be second, so mining industry is waiting someone else to start the mining activities in space. I don't know how it's going to happen. I think we're going to discuss this in panel soon. And then how we can transfer technology from mining to space. So the drivers are experience in robust and efficient equipment, experience in remote operations, expertise in resource extraction and processing. Mining industry knows this very well. Performing projects with high capital expenditures and high investment risks. Revenue generation expertise. Space was not focusing revenue generation. I mean, space exploration all about going there, mostly for science purpose. And safety culture and risk management, as I mentioned, developed in mining industry, developed for mining industry. Being a highly regulated industry, that may help to implement new technologies, transfer. Impediments, big market uncertainty in space resources, so prices versus cost. I mean, Jim already talked about it a bit, and also Marshall. And lack of innovation culture in mining, as I mentioned, no spin-offs. Size does matter. Big, not always good and better. That's, I think it's key. So mining industry's new motto, I guess, for me, small is the new big. As Jim mentioned about selective mining, what I say, precision mining. Reputation of mining is not good. And I think one of the big part is we don't have next giant leap for mining industry. And conclusions, I will pose some of questions, and I don't have really the answers. I got ideas. What is the mining industry's version of next giant leap? Is it critical minerals? I don't know. We can discuss that. To me, when the entire industry unites around a shared goal, it creates alignment, and alignment fuels collective action. Net zero targets could be the answer for it. Can mining industry deliver for the future? You saw the nice graphs from Jim, right? So it's actually inconvenient truth. No, I agree with Jim. Not with mining, with this performance of mining, we can't deliver for the future. Because according to International Energy Agency, thanks to Jim to highlight all of these graphs, which I didn't have time to put together for this presentation, we need to mine 6 times more minerals to achieve 2050 targets. That's why we can't deliver. We gotta do change, as also Jim mentioned. Then what the mining industry's big mission. So I'm gonna remind you again, these 3 zeros. Zero waste, zero emissions, zero human entry. Chile's mines are famous, right? But not only Chile's, on tailing dams we create. I took an amazing photo from the plane landing to Santiago. I believe, I'm not gonna name the company, but you may know that. Also, I know that one of the tailings dam size is bigger than Sydney in Chile. That's inconvenient truth. That's amazing waste we create. And also, all these processing activities, we got value from 1 gram in 1 ton. If you tell this to non-mining person, it's very scary. I said this to one of the ministers in Australia. He's shocked, 1 gram in 1 ton. So Australian chief scientist Katie Foley says that this needs to change. So, final conclusion, space mining, a mining industry is really not interested anything about space mining. They only interested technology transfer. Carlos can tell Rio Tinto was the first talking about this. Now they don't have an interest. Now BHP, Think and Act Differently Group, and Epiroc, as you heard from iSpace as well as Carlos. So they only interested on technology transfer. That's the truth. So we need to work on that. So Australia is very much ideal partner for space resources. Why? Because the world's largest mining companies operating in advanced mines, we know how to work in extreme environments. World's top universities in high caliber researchers and facilities. I mean, UNSW is one of them, as I mentioned. And then I like this quote from Anat Singh. She wrote, she's an anthropologist actually. She's talking about how human evolution impacting the industries in her book. It's called Not Yet. So space is not yet capitalist. Space is not yet colonized. Space is not yet mined. Space is not yet fully legally, technically, and economically governed. So stay tuned. I think we got to work all together. And finally, Carlos, I guess, mentioned about Harrison Schmitt. Harrison Schmitt, Apollo 17 astronaut, is the only scientist landed on the moon. All right? All the others were pilot. And he is geologist and he's still alive, and he sent me this picture to show what you're seeing here, the geology hammer he threw on the moon's surface and took the photo. It is real photo. He sent himself. That's a hammer. It's a geology hammer. Yeah, he threw his hammer on the space and took the photo in Apollo 17. Thank you very much for your attention.
Thank you so much, Serkan, for such a good presentation. And wow, Australia is doing a lot, from government, research, startups, and the list goes on. So, and very interesting concepts. I really would like to discuss more on the concept of zero waste, zero emissions, and zero human intervention. And I think we're going that anyway. But now I would like to invite our presenters to the panel. We're going to now have 20 minutes to get some questions from the public. So please come in. And Jim, are you still online? ¿Todavía tenemos a Jim en línea? Ah, perfect. Thank you. There he is. Bueno, vamos a hacer las preguntas en español y en inglés, dependiendo cómo vayan llegando las preguntas. Okay, let's check the microphones. And, bueno, primero en español. ¿Una pregunta? Ya. La pregunta es para los organizadores si vamos a poder compartir las presentaciones. Muy bien, sí van a estar disponibles. Muy bien, entonces en el panel tenemos en línea a Jim, el CEO de Offworld, el cual trabaja en actividades robóticas, AI y automatización. Tenemos a iSpace, que es una compañía de alunizadores comerciales. Y tenemos a Serkan como subdirector de un centro de investigación de Australia en University of New South Wales. Bueno, ¿alguna pregunta para nuestros presentadores? Tenemos la primera pregunta de este lado. Voy a pasar el micrófono.
Muy breve, sí. Voy a aprovechar el tiempo, entonces le voy a hacer la pregunta a los tres al mismo tiempo. I'm going to make the question to all three of you because we need to save time. Serkan, I follow your predicament of the 3 zeros. And yes, I mean, I understand that. But we also understand that our resources are not limitless, right? And we've been putting a lot of stress on it. So it's not an option. It's not about if miners are interested or not. It's about saving the world, right? So where do you find that breaking point? Where do you see, all three of you, where we really make the shift and start fooling around? You know, I don't want to insult anybody, but if we're looking at models that are with an ROI of 10, 20%, we're not going to make it. I think we need to really find models that go beyond 30, 40%. That's my impression.
Thank you. I agree. I'm a professor, I'm a researcher. And in last 10 years, I'm thinking about this 1 gram in 1 ton. It's really inconvenient truth, but that's, I mean, processing technology is really aiming to get this 1 gram and 1 ton is about gold, copper, etc. But if you look at most of the critical minerals like nickel, cobalt, they're much less, right? So all the processing technologies is aiming to earn more value from the mass we extract. So, but also we're creating an enormous environmental footprint. I'm more interested in reducing the waste. So all these 2050 net zero goals, mostly focusing on emission, it's a very good target. How close we are on that, I'm not sure. So BHP announced that by 2030, they will reduce emissions by 30%. Rio said that 15%. And they are very comfortable on achieving this. But how do they going to do 31%? They don't know. I mean, I don't know how they know how they will do it. This is the emission part, but they all linked, I guess. The waste and emission is very much linked. So currently, I mean, Chileans know very well, block caves are about 1,500 meters. In South Africa, deeper. But the Chilean and Australian stress regimes are different than South Africa, much more mining conditions in deep. So big mining companies really challenge is going deeper. So in 1,500 meters, rock temperature is over 100 degrees. you cannot use any of the equipment on that, as well as you can't send any people there. That's quite important. And, you know, I looked at all the existing mining methods. I mean, block cave is one of the Chileans are expert, 75 years old. So what we're trying to do, we trying to implement the advanced new technologies into 75 years old method. Basically, all our tunnels, Jim tried to mention that, I'm not sure he had a time, he can elaborate more. All of our tunnels are aimed to fit human being into tunnels. The typical is about 4 or 5 meters. I mean, human, like say 2 meters, and then putting in equipment 4 to 5 meters. Why? I think the technologies of world working, Jim mentioned, I think they are key. So we need to find a way of mining differently. That's why University of New South Wales have new initiative now called Next Generation Mining. Our aim is to develop new mining method, completely new, will start from the scratch, achieving zero waste, zero emission, and zero human entry. I hope I answered.
Thank you, Sergen. ¿Alguna otra pregunta? A ver, por allá. Voy a pasar el micrófono. Les voy a dejar un micrófono por acá y lo van pasando.
Hello, this question is for all of you. For you, what is the role of meteorite in the space mining development?
Puedo empezar. La pregunta es, ¿cuál es el rol de los asteroides?
Meteoritos.
Bueno, un meteorito te refieres una vez que entra a la Tierra, porque un meteorito es que pasó por la atmósfera y que recuperamos el... Bueno, es una pregunta yo creo que más para un... So the actual question is, so meteorites, once they go through the atmosphere and hit the ground, what's the role of studying meteorites in this context?
That's the sample, right? So having a sample from space, that's the most difficult. You know, Carlos already mentioned about 2 kilograms from there, 3 kilograms from the moon. We can only work with the simulants. That's artificial. So having those, I mean, we tried to get a 1 gram from Hayabusa. We went to competition, we didn't get it. For 1 gram, we can't do anything with 1 gram even, but it was very important, very precious. So meteorite is actually, we can learn more about space resources, even though going through the atmosphere, they lose a lot. And the big impact on Earth, they lose a lot. And I mean, I don't know, Angel is there? Is it Angel there? I mean, if anyone, a geologist in the room, they can talk more about. But I think it's very important to, as a first sample, the actual sample coming from space. I mean, Earth is also in space, don't get me wrong, but atmosphere is changing everything, I guess.
And to briefly add on the sample return, so currently all our lunar landers will land and just stay there for 2 weeks, the full lunar day, but we are developing notional capabilities to have a sample return similar to the Chang'e missions. And we'll learn a lot more when you have the lab, the sample back on Earth in the lab. It's much more impactful science than trying to do in situ measurements with your instruments.
Yeah, if I add a little bit to
Sí, bueno,
the
al final
meteorites.
los meteoritos son muestras de alguna forma gratis que llegan de Marte y de afuera del sistema solar, por ejemplo. Otra. Ángel, estás presente.
My question also is,
Ángel, please.
because I am geologist, I study meteorites. We study meteorites. And anyone talk about that? Because for us, it's very important when you analyze if these, studies are good or not, because you have samples from asteroid or from moon or from Mars for make some simulated about that. For that was the question.
Okay, I think we're going to pass the floor to Ángel. Ángel would like to answer.
Sí, sí me escuchan, sí.
¿Podemos prender el micrófono de Ángel Ubud?
Bueno.
Sí, ahora sí te escuchamos.
Sí, la pregunta es muy buena porque los meteoritos es nuestra conexión a los recursos de los asteroides. Tengo aquí en mi mano uno de los meteoritos más famosos, es el meteorito Allende tipo C, que en un momento dado nos puede dar la idea de qué tanta agua contiene, qué tanto carbón contiene. No sabemos exactamente de qué asteroide vino, pero con esto tenemos una forma de clasificarlos y esa es la manera que sabemos el tipo de recursos que existen en los asteroides. Los meteoritos son muy importantes, es un metálico en el que sabemos que tiene contenidos de platino y demás, y por ello son los mejores, como dijo Serkan, son los mejores samples que podemos tener para poder conectarlos con los asteroides, pero sí son muy importantes.
Gracias, Ángel. Tenemos otra persona en línea. ¿Es participante? A la siguiente. Perdón. Ok, muy bien. Perdón, ¿alguna otra pregunta?
¿En español o en inglés?
Como gustes, ¿para quién es la pregunta?
Para todos, realmente.
En inglés, por favor.
Yeah. Well, it's kind of strange to explain, but to all of you, how will you solve or like confront all these problem, I can say, of the time relativity in the moon? Because I don't know if it's quite different all the time, how will happen because of the theory of gravity relativity. So I don't know, maybe the time passes slower there and it's more easy, or maybe it's just not so different. That's my question.
Maybe that's a question for Jim or Ángel.
I think that the effects of relativity between Earth and Moon are pretty minor. It's more about the delay that you have between communications. En español. I'll say it in English. It's more about the delay that you have in the signal between the Earth and the Moon that you have to take into account. But relativistic effects between the Moon and Earth are so minor that that's not going to be a problem to operate the equipment, unless Jim has other way to look at it. But I don't think that's going to be a problem.
Yeah, I think the first settlers on the lunar surface will be using the volatile processing technologies to build several distilleries. So I predict that moonshine will be one of the first commercial products. And that will probably cause more of a lag and slowing time down than any physical effects.
And quickly, you mentioned that the time is not a huge factor from a relativistic perspective, but that reminds me of the concept of timing. So as we go to the moon, we're going to want to have infrastructure. Part of that's communications infrastructure or energy infrastructure, but we want timing infrastructure, PNT, precision navigation timing. So when we want satellites that will have chip-scale atomic clocks on it, and by able to triangulate between different satellites, we could create a GPS for the moon. Right now, there is no GPS for the moon, which is not a huge problem at the moment because there's relatively few activities happening. But when you have hundreds of different rovers and hundreds of different satellites that all need to know where they are in space and time, having a timing capability is very important.
Thank you.
Muy bien, gracias. ¿Alguna otra pregunta de nuestro estimado público? ¿Hay otras?
Gracias. Yo solamente quiero hacer un comentario. Como geólogo, hay datos publicados que caen a la Tierra más de 6 toneladas de meteoritos al año. 6,5 toneladas. Y eso se tiene que repartir en la superficie de la Tierra. Una parte importante en el mar, 70%, pero el otro 30% va a caer sobre los continentes. Y una fracción más chica sobre los desiertos. En ese sentido, Chile tiene una ventaja de que tiene grandes áreas desérticas donde se han encontrado muchos meteoritos importantes de distintos tipos, y también en Antártica cae una cantidad importante de meteoritos en cada año. Entonces, yo creo que esa es la materia prima, como dijo el profesor de Colorado, para entender qué nos está llegando del espacio, que después está procesado como, entre comillas, material terrestre, evolucionado a través de los fenómenos magmáticos. Pero es el primer paso para entender lo que nos viene del espacio, y probablemente hay metales raros en este momento de alto valor que no estamos aprovechando porque no hacemos mapas geoquímicos de la Tierra para saber qué otros metales tenemos aparte de los que están en cantidades grandes como cobre, plomo, zinc, etc. Pero todos los que están en las cantidades más pequeñas se usan en elementos tecnológicos de alto valor, principalmente microchips, electrónica, etc. Y algunos de esos son 100 o más veces más valiosos que el cobre, a veces 1000 veces más valiosos que el cobre, e incluso algunos más valiosos que el oro, por su importancia tecnológica. Entonces tenemos que conocer todo el rango de elementos químicos que hay a nuestro alcance en la Tierra. Mi segundo comentario es que yo no estoy de acuerdo con que los recursos terrestres se hayan terminado. Yo he trabajado por años haciendo exploración y trabajé 2 años en un proyecto donde estudiamos 1500 metros debajo de la superficie del terreno y seguían existiendo yacimientos de oro, de fierro, con cobalto, con vanadio, etc. Entonces nos quedan por lo menos 2,5 kilómetros, 1,5 kilómetros de corteza para empezar a explorar y explotar. Así que el agotamiento no es mañana. El problema es que la industria minera no se ha metido realmente, a mi juicio, en el tema de la energía. Hay que partir de la energía de formación de las moléculas para poder entender cómo yo puedo hacer la minería más económica posible. Y eso me lo dice a mí la termodinámica. Pero si yo parto con lo explosivo y me sale cantidad de tamaños de roca y empiezo a moler rocas que son muy duras, yo ya perdí dinero porque mi perspectiva de explotación está equivocada. Está equivocada desde el punto de vista de la economía física de los materiales que la dicta la termodinámica. Nosotros podemos estudiarla y utilizarla. De hecho, en nuestra empresa nosotros hacemos eso, buscamos los procesos más económicos posibles de extracción de metales. Y tenemos procesos que tienen realmente bajísimos costos de producción, menos que el 10% de todo lo que se está gastando ahora para sacar la misma cantidad de metal y a menor precio. Entonces hay un problema de utilización de la información que no sea completamente comprendida antes de empezar a abrir las minas. Una mina como Chuquicamata que llegó a 1,5 kilómetros, yo la conocí cuando tenía 450 metros, ahora están en 1,5 kilómetros, pero eso ya no es rentable. La ley de cobre es bajísima y estoy sacando muchas toneladas para sacar unos pocos kilos de cobre. Entonces hay cosas que hay que cambiar. Minería que se puede hacer subterránea, más eficiente que un rajo abierto que es muy caro.
Es un comentario muy, muy importante, y es la importancia donde el conocimiento que hemos adquirido en la industria minera en Chile, en Perú, en México, en Australia, en Sudáfrica, debe que ser compartida para el tema de los recursos espaciales. Y tienes toda la razón, estoy muy de acuerdo contigo, donde no nos hemos terminado los recursos naturales de la Tierra, pero como tú mismo lo mencionaste, las leyes altas, esas ya no las estamos terminando. Y por lo tanto, los tajos abiertos deben que bajar a más de 1 kilómetro, y por lo tanto tenemos que utilizar otro tipo de metodología como block caving, etc. Y ahí la pregunta es rentable extraer esos recursos minerales a 2, 3 kilómetros, o va a empezar a ser más rentable empezar a traer recursos de otro lado? Es una pregunta que hay que responder, ¿no? Pero al final la respuesta va a ser mucho con la energía que se necesita para extraer cada uno de los recursos. Muy bien, muchas gracias. ¿Alguna otra pregunta para nuestros panelistas? Todavía nos quedan 3 minutos.
Gracias. Me presento, yo soy Cristóbal, CEO de la empresa Petróleos y Biocombustibles. Somos una empresa donde fabricamos biorefinerías y hoy día todo lo que es la aeronáutica, o sea, sí, bien, el tema del combustible del SAF. Hoy día esto aplica también para la cohetería, los biocombustibles.
¿Podrías hacer la pregunta en inglés también? Bueno, ¿la podrías repetir una vez más, por favor?
Si hoy día la aplicación de los biocombustibles es efectiva en la cohetería.
He's asking about biofuels, if there is a role for biofuels for space systems.
Right. Yeah. Thank you very much. So at the moment, we're a bit limited in terms of different types of fuels that we can use. So there's kind of two big types. The first is called cryogenic fuel. So this is really exemplified by, for example, the Intuitive Machines engine uses liquid oxygen and liquid hydrogen. This can be very efficient, having a quantity called a high specific impulse, but it has comparatively lower thrust than other types of fuels. You also have things called storable propellants, and these are substances like hydrazine or bipropellant fuels. Our landers use these storable propellants. I think in the future, we'd have to make sure that any biofuels were able to be resistant to the space environment, how cold it gets, how the propellant behaves in the microgravity environment, how hot it gets. This is a very, so I follow the SAF biofuel debate on the aviation side, but to my knowledge, there's not been a lot of crossover to space applications.
Sí, claro. Bueno, lo que estaba él comentando son los diferentes tipos de propulsores, de combustibles que se utilizan para los aterrizadores, alunizadores de iSpace, los cuales no utilizan los biocombustibles. Sin embargo, lo que él mencionaba es que algo importante a tomar en cuenta es si se considera un tipo de biofuel, a qué temperatura puede trabajar, cómo se comportaría en gravedad cero, microgravedades, etc. Y que para su conocimiento, la industria aeroespacial sí está estudiando y considerando los biocombustibles, pero no la industria espacial. Entonces, ese podría ser una área, un campo de investigación, por ejemplo, en una de las universidades de Chile. Bien. ¿Alguna otra pregunta? Nos quedan 1 minuto.
First of all, thanks a lot for your very interesting presentation. And I have a doubt because how you think will be the way to define the reserve in the moon or asteroid? Because here on the Earth, you need a lot of very intensive drilling operation and carry out a lot of laboratory size because you need to define the size and the grade of the Earth.
Lo voy a responder en español. Básicamente hay muchas actividades de exploración que deben que suceder y hay diferentes instrumentos y compañías que están estudiando esa parte. No nos vamos a poder salvar de perforar, vamos a tener que hacer perforaciones. No vamos a tener el lujo de tener laboratorios, por ejemplo, en la Luna, pero sí van a haber laboratorios robóticos, en donde, por ejemplo, uno de ellos son los espectrómetros de masa, donde puedes llevar una pequeña muestra y te dice la composición elemental, ¿no? Entonces, en este momento lo que se está tomando en cuenta para la Luna, por lo menos, son laboratorios robóticos e instrumentos que van a ir en las perforadoras, en los rovers, etc. Pero el tema de exploración va a ser igual que aquí. O sea, vamos a tener que tomar muestras en la superficie, a profundidad, para subir la certeza geológica de cómo en la Tierra, de ir de recursos inferidos, indicados, medidos hasta las reservas. O sea, eso lo vamos a tener que seguir haciendo. Pero la tecnología va a cambiar. No sé si Ángel quiera añadir algún punto en eso.
No, tú eres el experto en eso, Carlos, pero la forma en que se definen las reservas, claro que en la Tierra hacemos todo ese tipo de perforaciones y demás, Pero tal vez al principio, si los fines son meramente empezar a sacar los primeros recursos o científicos, no se requiere tanto nivel de exploración, ¿verdad? Con comprobar que el hielo, por ejemplo, existe en la superficie o a 1 metro, va a ser suficiente para sacar esos recursos. Pero ya si queremos algo a larga escala, a mayor escala, definitivamente se va a tener que hacer como la Tierra.
Y en este momento, nada más para terminar ese tema, se está haciendo investigación inicial con satélites para encontrar, vamos a decir, los distritos geológicos. Dentro de esos distritos geológicos van a pasar satélites o hoppers de una forma más cercana para tener mejor resolución de esas áreas, y dentro de esos distritos geológicos encontraría áreas de exploración específicas. Y en esas áreas se va a tener que mandar rovers con perforadoras, tomar muestras, etc. Pero en este momento, me imagino que ustedes ya han escuchado sobre el uso de la inteligencia artificial para ayudar a reducir el número de perforaciones, en donde básicamente la inteligencia artificial dice, bueno, tomando en cuenta todos estos factores, en vez de perforar cada 5 metros en toda esa malla, perfora aquí, aquí y aquí. Entonces la inteligencia artificial nos va a apoyar en esa parte.
Y déjame nomás añado, porque Carlos mencionó que va a haber cerca de 30 misiones de aquí hasta el final de la década. Aquí es donde el tema inicial con que empezó este evento de la colaboración es importantísima. Porque Japón, India y Estados Unidos pueden hacer sus propias misiones, pero ¿por qué repetir todo? ¿Verdad? ¿Por qué no unirnos y cada quien aumente al nivel de información que se está haciendo, y así todos podemos compartir al menos el conocimiento de si son reservas, si son recursos? Pero sí se va a tener tiene que haber colaboración entre todos estos países y las compañías también, las comerciales.
Creo que tiene un último punto.
Sí, aprovechando que hizo el comentario, ¿han evaluado cuáles van a ser los potenciales efectos del uso del agua que está ahí? Porque está en equilibrio, puede haber un efecto mecánico en las rocas, un mini-sismo, etcétera, que puedan producirse, porque estás desestabilizando mecánicamente lo que ha estado ahí durante varios millones de años.
Es una excelente pregunta, pero antes de responder esa parte, hay que tomar en cuenta que hay agua en diferentes formas. Agua en forma de hielo, en el polo norte, polo sur, como permafrost. También hay agua estructural en los minerales, y también hay agua en vidrios, en glases. Claro. Entonces, si estamos hablando del agua en hielo en el polo sur, polo norte, hasta este momento, como no hemos perforado más de 1 metro, bueno, de hecho no hemos tomado muestras en el polo sur. De hecho, sí, cuando vimos la presentación, estamos tratando todavía de aterrizar en el polo sur, justamente para tomar muestras físicas con una perforadora y empezar a responder esas preguntas. Pero hasta el conocimiento que tenemos en este momento, y como Ángel también lo estaba explicando, la presencia de agua en forma de hielo viene de impacto de asteroides. Y si viene impacto de asteroides o cometas, entonces posiblemente los geólogos pueden responder mejor, puede estar en forma estratigráfica, ¿ya? Pero eso solamente lo vamos a responder una vez que empecemos a llegar con alunizadores, rovers, con radares y empezar a perforar.
Gracias. La última antes de entregar el micrófono.
Se la pasamos yo creo que a nuestro compañero.
Hablaron de reservas de agua en hielo. ¿Y cuál es alguna estimación de la reserva de agua estructural en las estructuras cristalográficas y mineralógicas?
Bueno, el tema del agua en hielo en este momento está en forma de permafrost, y toda la información que se tiene, como la describió Ángel, es por una misión donde básicamente se aventó un pequeño misil. Esto creó una nube, se sublimó, pasó otro satélite y con un espectrómetro de masa confirmó que había hidrógeno. O sea, esa es toda la información que tenemos hasta ahora de los polos. Perdón, la última pregunta.
Sí, no se preocupe. Estaba el primero, pero... No, en base a raíz del tiempo y colgándome aquí en la última pregunta, ¿ustedes cuánto estiman en tiempo para lograr estos objetivos?
¿Cuáles objetivos?
Estos objetivos de, obviamente, extracción de recursos y, obviamente, extracción de recursos y, obviamente, poder posicionarlo como objetivo determinado, porque no sé si ustedes están trabajando de forma complementaria con, Elon Musk en Space, tiene un proyecto de urbanización espacial en Marte y en la Luna, y para el 2050 ya proyecta más de 1 millón de personas estando viviendo allá. O más bien posicionarlos allá. pero son estudios y ya quedan 25 años. Estamos en 2025 y más bien sus objetivos, que obviamente tienen acá, tienen que ir de la mano con esto, porque si estamos hablando de urbanización espacial allá y también extracción de recursos, ¿cómo van ustedes complementando esas estrategias? Porque también pueden chocar con respecto a los otros objetivos que obviamente pueden tener las competencias.
Buena pregunta. Se lo voy a traducir a los panelistas. The question is regarding when do we actually see that this is going to happen in terms of ISRU? And how does this complement or conflict with the different goals that the different space agencies and companies have? Because ESA says, you know, we're going to be doing ISRU in 2030. And NASA maybe has a 2040. But Elon Musk has plans of colonizing Mars. So when do we think this is going to start happening?
Actually, I can, if I have a attempt to comment on that. I think that the first and the last questions tie in together very well. I would recommend thinking in three parallel scenarios or paradigms. The first is both for terrestrial and the space mining sector is we carry on as business as usual. The terrestrial mining sector, I think, has maybe 2 to 3 decades left of conventional mining before the illusions of scalability start to fall away and we enter an existential crisis. On the space side, this business as usual scenario involves us taking incremental steps from a technology development perspective. In that paradigm, we may be looking at another 30 to 50 years of step-by-step development. And despite our great hopes and dreams of expansion. So first paradigm, business as usual. Second paradigm, if we want to accelerate what we're doing both in terrestrial mining and space mining and expansion, it is a case of adopting faster development curves, taking more risk, killing more people, and risking more capital. It's not going to be pretty. We need to break the rules. We need to break laws. We need to redefine treaties. And we need to understand what are the real priorities for this generation responsibility for the civilization that we hope to build here on Earth and in the inner solar system. And the third paradigm I would recommend thinking about, and it's really only the kind of people sitting in the room here in the audience and on the esteemed panel that are really able to connect these dots together. And I think, Carlos, you put it very well in the context of the 16th, 17th, 18th century expansions. And Serkan, you mentioned this as well, that we really, the first and second paradigms are not going to be enough. We need to really think of building new countries, new nations, going out and opening up new frontiers and building new cities and new nations and conquering lands. And I know there is a lot of, there's a lot of cultural resistance to talking in terms of colonization, anything that does not allow for equanimity or equality of outcome. But meanwhile, the clock is ticking. We only have so much hydrocarbon resource that we can afford to extract terrestrially. Right now, I don't see us scaling beyond 20 to 25 terawatts of power with hydrocarbon technology if we don't do something to circularize the economy or open up industrialization to build space-based solar power in the multi-hundred terawatt scale capacity before the end of the century. And so we really need to think big, and we need to think intelligently about how to go from here to there of what is the biggest push that humankind has ever seen. And we need to do it quickly, we need to do it systematically and robustly. So I think it calls for a shift in mindset, the scale of which we've never seen and the urgency of which has never been upon us before.
I mean, I agree with what Jim says, but he didn't answer your question when. I will answer in our lifetime. I don't know exact date, year, depends on agencies, presidents. In our lifetime. We'll see. All of us will see. Gonna happen. That's what my answer is. Saying the first paradigm, what Jim said, in our Off-Earth Mining Forum in September this year, we will discuss, the topic is actually space mining, one industry or two. I think that's quite important.
And this is a big debate in the United States space policy circles right now. A lot of it depends on NASA budgets and NASA funding. But if SpaceX Starship is successful, landing on the moon in the early 2030s or before timeframe, the capacity that brings will enable a lot of this to switch. It will be a step function. So a lot of it depends on, do these larger vehicles, are they successful?
Bueno, muchas gracias por sus preguntas. Hemos llegado al final de este panel y por favor démosle un gran aplauso a nuestros panelistas y presentadores.
Carlos.
Gracias.
Bien,
Carlos.
Bien, muchas gracias.
Ángel, perdón,
Carlos.
un punto.
Muchas
Tan
gracias.
solo para desearles buen provecho y que se coman unas empanadas, unas humitas y un pastel de choclo a nuestra salud.
Gracias,
Sí,
Ángel.
Qué bien, qué bien. Bien, muchas gracias, Carlos, al panel. Gracias a las personas que están online por este gran panel. Nos entusiasmamos mucho, dado que este es un hito cierto especial para nosotros, fundacional, y grandes panelistas, autoridades en estas materias. Uno se entusiasma, ¿cierto? Y vale la pena poder escucharlos. Vamos a volver a las 4 de la tarde. Vamos a hacer un sacrificio, ¿cierto? A hacer breve nuestro break para no esperar al próximo panel, que va a ser tecnologías relevantes para la industria minera espacial y terrestre. Entonces volvemos a las 4, a hacer el esfuerzo, comemos rápido y volvemos. ¿Bien? Hay un restaurante abajo, ¿cierto? Que pueden ir y comer algo, ¿cierto? Rápidamente. Nos vemos, muchas gracias. Los esperamos de vuelta. El panel que viene es muy bueno, muy bueno.